I invite you all to our campus to come and interact and see what we are doing, and allow us to learn from you, and you can also learn something from us. And very very warm and happy learning experience right now. I wish you all a very warm and happy learning experience. All the best. Thank you.
Thank you, sir. Thank you for your wonderful speech. So now I'd like to call Mr. Dr. Ravi Kishore Singh, our principal sir, in an alumni of RAC, now MNIT Jaipur, MTech from IIT Bombay, and PhD from Geetam deemed to be University. The professor has served Indian Army in the Corps of Electronics and Mechanical Engineering for 20 years before hanging his uniform as he is as rich industrial experience as Army officer, managing workshops, and has been teaching faculty for more than 6 years while in services. He started his career as teaching assistant at MNIT Jaipur for 1 year before joining Army professor. He has served for more than 16 years after premature retirement from the Army services in year 2005. He has served as HOD, Vice Principal, Associate Director, and Principal of Engineering College before being approved as Principal of this institute. The professor had hands-on experience on high-tech electronic equipment and has done many courses on radars and simulators. He has published many papers on radar signal processing and microstrip antennas. He is an panel of JNU Delhi for MTech dissertation for Faculty of Electronics, Military College of Electronics and Mechanical Engineering. And I'm welcome you, sir.
Good evening, ladies and gentlemen. I hope I'm audible.
Yes, sir, you are audible.
Okay, in this series of FDPs, which are being conducted by Lord's Institute of Engineering and Technology, first I welcome you to my institute. And the series of FDP, we just now finished FDP on biomechanical on 3D printing by ECE also, and this is third in the series ATAL FDP by civil engineering. I congratulate Dr. Fariguddin, who is my HOD, also the Department of Civil Engineering for being an host to this FDP. Sustainability innovation in civil engineering. It focuses on developing environmentally friendly, cost effective, and last long infrastructure. A lot of applicability of AI and virtual reality is on in the scene. The things which we need to concentrate on are sustainable materials, energy efficient construction, smart infrastructure in terms of IoT based monitoring, AI and BIM integration, sustainable water management, and carbon reduction techniques. All of you are quite aware that a lot of recycled materials have been used in construction, like fly ash, slag, plastic waste, etc. in near future. We also have self-healing concrete, which contains bacteria or capsules that automatically repair cracks. Net zero energy building are designed to generate as much energy as they can consume. Maximum natural ventilation and light to reduce energy consumption. I'm very sure that this session which you're going to have in next 4 to 5 days will be very educating for all faculty members, not only for civil engineering, but other branch associated branches also. Since we run construction management and uh, construction management, and also we have a MTech in transportation. So we our department is very strong. Like was said by Vice Chairman, we are offering consultancy to GHMC, and we have a separate lab for that. So how I wish the faculty members from other institute come and visit us, and also would like to see you if you have something important at your institute. At the outset, once again, I'll congratulate my team of civil engineers, excellent team which has been dedicated and with a long period of retention. I'm sure my team is going to produce a wonderful FDP for all of you, very educative and very thought provoking to come. I am sure a lot of panel discussion, a lot of group discussions would be there to clear all the doubts, to clear all the issues for sustainability. With this, I hand you over to Jalal. Jalal,
Yes,
thank
sir.
you, and thank
Thank
your
you very much.
HOD and your team on my behalf to conduct such a beautiful session. Thank you so
Thank you.
much.
Thank you
Thank you.
very much, sir.
Thank you very much, sir.
Thank you very much, sir. Thank you for wonderful speech, sir. And I would
Thank you.
like to call, hello, I would like to call our HOD sir, Dr. Khaja Fariduddin sir, as the convener of our upcoming faculty development program, FDP and Sustainable Innovation Trends in Civil Engineering. I respectfully request your leadership in ensuring the successful completion of this event. Your 25 years of teaching experience and 2 years of industrial experience in transportation engineering would undoubtedly provide invaluable guidance to our participants. Your expertise would greatly enrich the knowledge and understanding of our esteemed faculty members. We believe your contribution would be instrumental in making this FDP a resounding success. We would be honored if you could lead this event and share your insights with our participants. Thank you, sir.
Thank you, Mr. Jalal, to
Thank you, sir.
Assistant Professor, Civil Engineering Department. At the outset, I welcome all the participants of this prestigious ATAL FDP, which is going to commence shortly. We are in the inaugural session. So without taking much of your time, I would like to highlight few points of this particular FDP. Sustainability is the theme of this particular FDP. The broad definition of sustainability is to use the available resources very judiciously so that our future generations should not be deprived of when they try to use it. So we have to use it and reuse it. That is the main theme behind it. So in this context, the construction industry itself is transforming, and they are increasing the efficiency by keeping a goal of sustainability at the same time without compromising on the safety aspect. For a built, resilient environment, sustainability is very much essential to prevent the environmental impacts and to provide eco-friendly infrastructure. There are a few examples which I would like to quote here. Sustainable materials and technologies mainly involves recycling of the material. Instead of disposing it, how to recycle it. Then comes the energy harvesting concept. In that, we are trying to generate electricity by the vibrations induced by the moving vehicles. So, and apart from that, introducing solar panels into the buildings and designing the energy efficient buildings. And the third concept is water management, wherein we are going to make use of rainwater harvesting and also designing the water efficient systems. Then comes the waste reduction and management. As far as possible, the waste should be minimized. If they are generated, they should be reused. This is the concept which is there in circular economy. We call this concept as circular economy. We are not allowing the economy to go waste. We are using it and reusing it. Then the sustainable transportation initiatives, which involves promoting the electrical vehicles so as to reduce the consumption of fuel, which is very scarce. Then comes the innovative designs. Nowadays, civil engineering designs are being done mainly by using BIM technologies and all. So these are the concepts that are there under sustainability. So we have made this FDP happen by joining hands of academia, industry, and research-oriented professionals. So you will have amalgamation of all these professors from NITs, various reputed universities, various reputed private engineering colleges. Then we have researchers from research institutes. Then we have industry experts. They have all joined hands and they have tried to come up with this particular FDP titled Sustainability Innovation Trends in Civil Engineering. With this, I would like to hand over my mic through Mr. Jalal sir to our coordinator, Dr. Imtatullah Khan sir.
Hello. Hello. Sorry for interruption, guys. Thank you very much, sir, our HOD sir. And now I would like to call Dr. K. Muhammad Imdadullah Khan sir, who is the coordinator of our FDP and associate professor of civil engineering department in Lord's Institute of Engineering and Technology. So now he will focus on some points and for the participants. I would like to call Mr. Dr. K. Muhammad Imdadullah Khan sir. Yes sir, you are audible sir. You can continue.
Yes. Thank you, Mr. Jalal sir.
Thank you sir.
Good evening and welcome to all for this ATAL FDP program. First of all, I want to thank our institute for giving me as an opportunity for apply ATAL FDP. Then I want to thank ATAL for accepting our application. Finally, I want to thank our participants. Thank you and welcome you all once again. I want to share some ATAL guidelines for participants. We prepared section schedule as per the guidelines of ATAL FDP. So based on that, already we shared our section schedule through our WhatsApp and email also. Then based on our section schedule, we have total 13 sections. From day 1 to day 6, day 5, we have 2 sections, and 6th day we have 3 sections. The day 1 starts from 6 p.m. and ends 9:30. From day 2 to day 5, section starts 6 p.m. and it ends 9 p.m. And 6th day, end of the day, FDP day, the section starts from 2 p.m. and it ends 8 p.m. with validatory. Before validatory, we have feedback section and question test for based on this our sustainability innovation trends in our civil engineering. So for the day 1, the speakers which are Dr. Atun RoyChoudhury, Dr. G.Mallikarjuna Rao. Day 2, Professor P. Rathesh Kumar and Dr. D. Annapurna. Day 3, Professor Manzoor Imtiaz and Dr. Ashok G. Mathani. Day 4, Dr. Krishnamurthy and Dr. Harish Kumar Agare. Day 5, Mr. Aravind Singh and Dr. C. Kalyana Rama Joshile. Day 6, Ms. Hajira Fatima, Dr. Abdul Al Maun and Dr. Sheikh Mohammed Rasul. So these are the speakers will engage this FDP section through these 6 days. So based on this ATAL FDP guideline, all the participants should maintain to receive the certificates, you must at least 80% attendance and score at least 70% of assessment. It is mandatory to all, or else your certificate will not be issued by ATAL FDP. After the end of the day, 6th day, well, 13 sections were completed. Then we have to do feedback and question and answer section. For that, some test is there based on this our ATAL FDP. So the feedback section is mandatory to this certificate generation. If you are absent in this feedback section, the certificate will not generate. Keep it. These 3 things. What are that? Attendance at least 80% and score 70% in assessment. Feedback, filling feedback is mandatory. These 3 things is mandatory for all. So I hope all the participants will cooperate as to successful completion of this FDP. Once again, I welcome all and I hand over this section to Mr. Jalal sir. Then our first participant, resource person, will take Mr. Dr. Atun RoyChoudhury. Please, Jalal sir.
Hello sir. Thank you very much sir. our coordinator, sir, from FDP. So now I would like to call our first session going to start now. Our speaker is Dr. Atun Rai, sir, Assistant General Manager in Cube Bio, avid researcher, editor, reviewer, and gold medalist, and most importantly, TEDx speaker. And he's a alumni of BITS Pilani. Now he is a reviewer and editor to many international and national journals. Now hand over the session to Dr. Atun Rai, sir. Hello, sir.
Yes, Professor Jalal.
Yes, sir.
I can hear you.
I will hand over the sessions. First session to you, sir.
Thank you.
Thank
Thank
you.
you so much. Thank you so much. So
Thank you,
thank you
sir.
so much for the warm welcome and the introductory talk. Thank you so much, all the faculty coordinators, student coordinators. I can see a huge crowd of more than 250 people. Definitely not not something very easy that can be tackled. A phenomenal job put in by both faculty and student coordinator. And thank you so much for the opportunity in first place. Thank you so much for having me here today. On this note, without wasting any further time, I would like to proceed actually. So I'll turn off the camera. It might be taking more bandwidth. So I'll turn off the camera while talking. Once the session gets over, then probably I would be open to take questions for 15-20 minutes. We can have one-on-one discussion. And in the meantime, if you have any question, you can put it on chat box. So somebody from faculty team, I would request, please keep a track of the questions. And once the session gets over from my end, at least my delivery portion is over, please do post me those questions, one up to the other, so that we can address the queries and we can proceed accordingly. So on this note, I'm beginning the session. Thank you so much.
Yes, sir.
Yes, please.
Yeah, okay, sir, sure.
Right.
You can continue.
There's a queue. Right. Just give me a moment. I'll share the presentation. Is my screen visible to you guys?
Yes, sir.
Right. Thank you. Thank you so much for acknowledging. Moving forward, the topic that had been assigned to me is in and out of hazardous waste, its management, and legislative guidelines. When you're dealing something with waste, which is hazardous in nature, definitely guidelines and legislations play a very crucial part. So automatically, we will begin with the guideline, what exactly our pollution control board mandates, what they advise, what they says, and furthermore, how exactly it's supposed to be tackled and what's happening on-site condition. So I have a case study from Hyderabad, which is called Hyderabad Waste Management Project Private Limited, HWMP. It's a TSDF facility, treatment, storage, and disposal facility. So the TSDF, what's written here is treatment, storage, and disposal facility, and any facility which is engaged in handling and management of hazardous industrial waste is termed as TSDF. Okay. Moving forward, these are the following content of the PPT. First of all, we'll discuss what is hazardous waste, based on what criteria or characteristic we can classify a waste as hazardous waste, what are the legislation or guidelines related to it, which are typically pertaining to India, hazardous waste characteristics, hazardous waste management. So once we start managing the waste, there are further subdivisions of handling it properly, which includes collection from the point of generation, transport from point to TSDF, temporary storage at the TSDF facility until and unless the disposal pathway is derived and designed, and then final treatment, stabilization, disposal, and if possible, and if the protocol permits, then resource recovery. These are the topics we are going to cover today. So if I try to define hazardous waste, instead of reading the definition, which is already encrypted here, you guys can read it. Instead of doing that, I would probably try to emphasize on this following points. You can see reactive, toxic, flammable, explosive, or corrosive characteristics. So any waste, when it depicts any of these characteristics, which either it is reactive or toxic or flammable or explosive or corrosive, then we categorize that waste as hazardous waste. It can depict any of these categories or all of these waste characteristics. In either of the cases, the waste will be categorized as hazardous waste. Moving forward, what is toxicity, what is reactivity, what is flammability, what is explosive nature, what is corrosivity? We will discuss individually all these points. Moving forward, what is the chronology, what is the history of acts that had been actually in place in India? So the first act which is applicable for hazardous waste management or legislation related to it is Resource Conservation and Recovery Act, RCR, in 1976. So basically, there is a term very gaining immense popularity these days, which is circular economy. So circular economy stands for cradle to cradle. That means when the product is produced, it is converted into waste. Waste is again handled and reconverted into another byproduct which can be reutilized. But in case of haz waste, mostly the cradle to cradle approach does not work. The approach here is linear economy, which is cradle to grave. That means the waste is produced, it is highly hazardous in nature, and there are some certain risk factors associated with it. That is why mostly circular economy is something is not associated with hazardous waste. Mostly hazardous waste undergoes a linear economy where the waste is produced without any resource recovery. It is treated, stabilized, and disposed. That is how hazardous waste is supposed to be taken care of in most of the cases. Now, coming to point number 2, Toxic Substances Control Act. It actually prohibits the manufacturer for use of certain hazardous chemicals. That means, let's say for your production, you require BTX, benzene, toluene, and xylene. So benzene, toluene, and xylene, it is permitted for certain industry and prohibited for certain industry. So under this act, we would get to know for which are those industries for which this BTX use or consumption is prohibited. Okay. Moving forward, row number 3, Comprehensive Environmental Response, Compensation and Liability Act, 1980, and then SARA. Now coming to point number 5, which is most important, Hazardous Waste Management and Handling Rule, 1989, and its subsequent amendments. So the first introduction was under Environmental Protection Act in 1986, which was introduced later on. The hazardous waste management quotient was actually incorporated into it in 1989, and subsequent changes came in 1993, in 2000, 2003, 2008, and so on and so forth. Okay. Last amendment, which was the major amendment, happened in 2016, where newly introduced guideline incorporated transboundary movement in the sense state to state movement of hazardous waste, which was recently under discussion all across social media, newspaper, web, everywhere. You must have come across this news, I'm pretty sure, where from Bhopal, everybody remembers this Bhopal gas tragedy, right? So from Bhopal, waste moved to nearby haz waste TSDF facility. I don't want to name any specific location here due to controversial reasons. So from Bhopal, whatever the waste after primary stabilization or pre-stabilization, we can call it, waste in closed vehicles, in closed conduit vehicles, moved to the nearby treatment and storage facility, TSDF facility, which is again within the same state, irrespective of the transboundary movement. As because waste, which is highly toxic and hazardous in nature, moved from one place to the other, there was a big controversy associated with it. Anyhow, Pollution Control Board had been closely monitoring the incineration facility where the waste was getting burned, and the amount of, what quantity and quality of smoke that is coming out, what is the level of different pollution concentration in the smoke through continuous emission monitoring system. Anyhow, CEMS is now a mandate for hazardous waste. So any stack or chimney after burning of hazardous waste, whatever the smoke is coming out from the stack or chimney, it has to be online monitored 24/7, and the monitored data will be logged in Pollution Control Boards in their database 24/7. If there is a change or if there's a mismatch in terms of quality, automatically there will be humongous amount of penalty laid on you. Okay. Post 2016, lately, the last amendment in hazardous waste management rule was in 2022. And in 2022, they further strengthened the idea of EPR, extended producer responsibility. Now, what is an extended producer responsibility? It is, as the name states, it's a very simple term. Okay. If somebody is producing hazardous waste, they need to take the responsibility of its disposal. And it is not only applicable for hazardous waste, but also applicable for plastic waste. Major FMCG industries, for an example, Patanjali, let's say for their biscuit manufacturing unit, they are consuming 5,000 tons of plastic packaging material every year. So they need to mandatorily treat under this EPR scheme, they need to mandatorily treat 5,000 metric tons of waste plastic. Otherwise, they will be laid with humongous penalty, and there's a chance that the facility might be seized by Pollution Control Committee. Okay. So now let's try to understand what this hazardous waste management guideline talks. There are totally 26 rules. Okay. 7 schedules. And out of those 7 schedules, there are 3 schedules, 1, 2, and 3. Especially in 3A, B, and C, which are very, very important. So in Schedule 1, hazardous waste management identifies 36 industries which typically eligible or entitled to produce hazardous waste. 36 industrial processes were identified which supposed to generate or produce hazardous waste. They were depicted under Schedule 1. What Schedule 2 depicts? Concentration limit under 5 classes, which starts from 50 milligram and it goes up to several thousand milligrams. Okay. Based on each class, there is a concentration limit for every category of hazardous waste. I'll discuss about all these things in the forthcoming slides in details. So don't worry. We'll have individual discussion about all these slides. Moving forward, class 3A and B, it talks about imports and export. Import and export in the sense from one state to the other state. So let's say I have a facility in Hyderabad, which is importing hazardous waste from Andhra Pradesh. So definitely there are some certain protocols associated with it. So we'll discuss about that as well. And number 3 is waste characteristics. Number 3C, Schedule 3C, talks about waste characteristics. What are all the waste characteristics we should actually determine? Okay, we should actually analyze. And based on that, how we're supposed to derive the treatment scheme for that. And there are 15 forms. Out of those 15 forms, 6 forms are very, very important, which are color coded, which includes colors such as white, yellow, pink, blue, red. So I'll individually discuss about all those forms. They are mostly connected to the transport of hazardous waste from the point of generation to the point of treatment and disposal, and disposal. Whatever the disposal had happened, that information sharing with the Pollution Control Board. So we'll talk about those forms as well. Now, in this slide, I told about Schedule 1. So now here is the detailed description of Schedule 1. So what I told earlier on, there are 36 industries categorized, or 36 industrial processes categorized, which tend to produce hazardous waste during any of their unit operations or all of their unit operations. So Schedule 1 gives you complete idea about this 36 industrial processes and 115 subcategories under them. Okay. Moving forward, Schedule 2. Schedule 2, as I told earlier, it's supposed to give you the concentration limit, under which concentration limit, how exactly this hazardous waste is supposed to be classified, whether they have to be classified as class A or class B or subsequently to class E. I actually depicted the information, delineate the information here. So concentration limit up to 50 milligram per kg means it will be categorized under class A. Up to 5,000, more than 50, less than 5,000 milligram per kg means class B. More than 5,000, less than 20,000, it will be categorized as class C. Class D, between 20,000 to 50,000. And class E, characteristics based on regardless of concentration limit. For an example, there are different subcategories E1 to E4 and E5. So flammable, explosive, corrosive, toxic, carcinogenic, mutagenic, endocrine disruptive, all these categories. Okay. Now, under class 3, part C, under class 3, there are 3 parts, as I told earlier. Class A is important, class B is important, and class C is important. So class C talks about different characteristics under which any waste can be categorized as hazardous in nature. So the first one is explosivity. Second one is flammability, flammable liquids. Any flammable liquid will be categorized as hazardous. Any explosive, any firecrackers that we are blasting during celebrations, they are they are categorized as hazardous. Any flammable solids like alternate fuels, they are categorized as hazardous materials. Substances or waste liable to spontaneous combustion. That means, for an example, if it catches fire, automatically it will start burning and it will continue to burn. They are categorized as hazardous. Can you give, if I try to give you an example of that, what would it be? Alternate fuels again, okay, because of the higher calorific value. The other one is substances or waste in contact with water emit flammable gases. Let's say, for an example, cyanide. So cyanide, when it comes in contact with H2O or water, it forms a gas called hydrogen cyanide. So hydrogen cyanide, if we inhale, if we take the vapor inside, it is acute. It possesses acute toxicity. It's highly toxic in nature. Oxidizing agent, anything which is highly oxidizing in nature or highly, alkaline in nature. That means they are reactive in nature. Their pH value is either very low or extremely high. So those things, any agent which is, poisonous in nature, like if we consume, it will poison us, acute poisonous. Any infectious material, for an example, biomedical waste, waste from healthcare establishments, from hospitals, nursing homes, pathological centers. Okay, so these are the different categories under which hazardous waste is generally fitted in. Now we'll talk about CRIT criteria. This is the fundamental criteria under which generally waste is termed as hazardous. What is CRIT? CRIT stands for corrosive, reactive, ignitability, and toxicity. So if the waste is either corrosive or reactive or ignitive, it shows ignitability or toxicity, then it will be characterized as hazardous waste. Now, as I told you earlier, for all of these categories, for all 4 categories of CRIT, I'll be giving you individual definitions. So what is corrosivity? So corrosivity is something which can corrode steel greater than 6.35 mm per year, or at least at a temperature of 55 degrees Celsius. Then it will be termed as corrosive in nature. Any liquid with a pH less than 4, which is highly acidic in nature, or pH more than 12, which is highly alkaline in nature, they will be termed as corrosive. Now, what is reactivity? Reactivity is waste which is at normal room temperature. It starts reacting with anything. For an example, sodium metal. If you keep it in open atmosphere, it will start burning. So it is highly reactive in nature. So that is why it is categorized as hazardous. So there are 3 different categories under reactivity. Normally unstable and readily undergoes violent changes without detonating. Detonating means blasting. Without blasting, it will undergo different level of changes, which are like very rigorous. Okay. React violently with water and forms potentially explosive mixture with water. Okay. And then cyanide or sulfur bearing waste, when exposed, can generate toxic gases, vapor, or fumes. As I told you earlier, cyanide can mix with water and produce hydrogen cyanide gas, or it can mix with other sulfur bearing waste or other acids, and it can generate again another carcinogenic and harmful gases. What is ignitability? It's a clear-cut definition once again. Liquid containing more than 20% of organic by volume and has a flash point less than 65.5 degrees Celsius. That means in 100 kg, the organic percentage is more than 20 kgs, and the flash point means at what temperature it will catch fire. It will start burning. That is called flash point. So the flash point is less than 65.5 degrees Celsius. not a liquid, this is for liquid. If it is not a liquid, if it is in solid state, if it is not a liquid and capable of causing fire through friction, absorption of moisture, or spontaneous chemical reaction. Okay, and an oxidizing substance, when it come in contact with moisture or other waste, results in spontaneous fire or combustion. So these are the definition of ignitability. Now, what is toxicity? If leachate from the sample contains particular contaminants after analyzed by TCLP. What is TCLP? TCLP stands for toxicity characteristic leaching procedure. Okay, so when you are trying to understand if the waste contains moisture and if some certain amount of liquid supposed to ooze out because of the moisture content in the solid waste, in that liquid, in that sluddy kind of thing, what will be the concentration of different kind of pollutants, different kind of contaminants? That is actually analyzed by the test called TCLP, toxicity characteristic leaching procedure, because this liquid leaches out from the solid. So the contaminants that we supposed to check the concentration for is arsenic, barium, benzene, cadmium, and carbonate tetrachloride. Okay, so the TCLP limits are provided here. So if it exceeds any of these limits, then it will be considered as toxic. If the arsenic level exceeds more than 5 milligram per liter, then the particular waste will be called as toxic. Similarly, it is applied for the other 4 contaminants as well. So now we understood how the waste is supposed to be categorized as hazardous waste, based on what characteristics, based on what phenomenon. But how exactly this hazardous waste is treated, this process flow is presented here. So once the waste is generated, it has to undergo a comprehensive analysis. So this comprehensive analysis, it gives you an idea how much amount of what is the characteristic of this waste. What is the characteristic in the sense? This comprehensive analysis includes some 100 of parameters, which includes the pH. It ranges starting from pH value. It goes into paint filter liquid test, TCLP, WLT, moisture content, flash point, many parameters, like hundreds of parameters altogether. So in the forthcoming slides, we'll talk about those parameter values. Okay. Once the comprehensive analysis is done, you will get to know what is the quality of the waste. Okay. What is this waste type is. Based on that, you will fix up some certain waste acceptance criteria. And based on this waste acceptance criteria, you will do a test called fingerprint analysis. What is a fingerprint analysis? Let's say out of those 100 parameters, you have identified some 5 parameters which are very, very crucial. And this 5 parameter for every batch of waste that you are accepting from waste generator. This 5 criteria for every batch you will test, and you will check that against the criteria of comprehensive analysis. Okay, and you will see whether it's matching or not. If there's a mismatch, once again the waste has to undergo, there is a change in the characteristic, then once again the waste has to undergo comprehensive analysis. Based on that, once again another disposal pathway has to be decided. Now when I say disposal pathway, decision on disposal, there are 3 different criterias, or rather 4 different criterias, which are actually approved by Pollution Control Board. So the first one is direct landfillable waste, DLF. Second one is landfill after treatment, or LAT. The third one is incineration, and the fourth one is co-processing, which is typically reuse. Co-processing in the form of AFR, alternate fuel and raw material for cement industries. Okay. So once we take the decision on disposal that this waste is hazardous waste, then it has to be transported to the nearby TSDF facility, treatment, storage and disposal facility, where after transportation, waste will be undergoing fingerprint analysis. Post fingerprint analysis, during fingerprint analysis, it will be kept under temporary storage under lock and key. And this post fingerprint analysis, it will actually get treated, and post treatment it will get disposed of, and disposal will follow these 4 pathways as I told earlier. So in comprehensive analysis, as I told earlier, some hundreds of parameters we need to check in and out, which starts from easy parameters such as what is the physical state of the parameter. Then it moves to color, texture, specific gravity, viscosity, calorific value, flash point, PFLT, moisture content, loss on ignition, loss on drying, pH value, reactive cyanide, and reactive sulfide percentage. These 2 are very important parameters, because if it exceeds a certain limit, automatically there's a possibility of leakage of hydrogen cyanide gas into the atmosphere. Oil and grease level, carbon percentage, nitrogen, hydrogen. Through ultimate analysis, we'll get to know all these things. Organic parameter, basically. For liquid waste, as I told earlier, organic parameter should not be exceeding 20% of the value. So that is why this organic parameter analysis is very, very important. If it exceeds 20%, automatically it will become inflammable. That means it will start burning. What are the laboratory instruments in general we use for this parameter analysis? It includes gas chromatograph. Gas chromatography is for detection of unknown compounds. Let's say you have received some waste. You don't know in and out what is going to be the characteristics of that waste. So for that, gas chromatography is generally used. There is GCMS, gas chromatography and mass spectroscopy, FID, ECD. These are different kinds of GCs with attachments. Okay. Then ICP-MS, induced coupled plasma. Induced coupled plasma is typically used to know what is the heavy metal concentration, like zinc, cadmium, chromium, nickel, arsenic, all those heavy metal. There are 7 heavy metals in general we check. So those heavy metal concentrations supposed to be evaluated with the help of ICP-MS. Okay. CHONS and CL analyzer, that is again typically for proximate analysis. What is the distribution of CHON and SP? Bomb calorimeter. Bomb calorimeter is for calorific value. Calorific value in the sense that actually helps understanding whether the waste goes to the landfill or whether the waste supposed to go to the incineration or for energy recovery in cement industry. So if the calorific value, the thumb rule is if the calorific value is more than 3000 kilocalorie per kg or calorie per gram, then in that case, that waste will be categorized under either incineration or AFR, alternate fuel and raw material category. Flashpoint analyzer. Flashpoint analyzer is to check what is the flash point. As I told earlier, the flash point should not be below 65.5 degrees Celsius. Otherwise, in open atmosphere during summer, there's a possibility that it might catch fire on its own without ignition. UV visible spectrophotometry. Again, UV visible spectrophotometry is for analysis of different concentration, like for an example, chromium concentration. Waste from mining industry. Mining industry, like chromium mine or other mineral mining. Chromium or hexavalent chromium is one of the major constituents which is there in the waste. Hexavalent chromium is highly hazardous in nature. And before disposing of into the landfill, this mining waste, hexavalent chromium supposed to be stabilized and converted into trivalent chromium. So for that conversion purpose, we use a stabilizing agent called sodium thiosulfate in combination with lime and fly ash. Now somebody may ask me, why lime and fly ash? Because lime and fly ash, when combined, lime is an agent which converts fly ash into pozzolanic fly ash into cementitious fly ash. So fly ash is pozzolanic in nature. When fly ash added with 5% of lime, it gets converted into cementitious in nature. Cementitious in the sense it develops binding property. Okay, binding property means if I try to put the waste inside lime and fly ash and add some water into it and try to form a mixture, it will solidify just like concrete block. Okay, so that is why UV visible spectrophotometry is required to analyze the concentration of different parameters. For an example, hexavalent chromium. Okay, flame photometer KF titrator, TCLP, as I told you, these are all like ancillary equipments. TCLP, as I told earlier, if waste A is taken into consideration and if leachate comes out from that because of higher moisture content. So what is going to be the concentration of heavy metals in that leachate, and whether it is poisonous or non-poisonous, it possesses toxicity or not, it is actually determined from TCLP. Like for an example, as I told earlier in the previous slide, here you can see arsenic, barium, benzene, cadmium, all these concentrations we check with the help of TCLP, and the concentration limits are also presented here. Moving forward, hazardous waste collection and transportation. So source segregation based on the category of haz waste. Source segregation for hazardous waste is a must. Okay, and hazardous waste can only be stored in high density polyethylene sacks, steel drums, which is typically stainless steel category, so that it should not be corroded because of the corrosivity of haz waste. HDPE drums, MS containers, mild steel containers with epoxy coating, so that mild steel directly should not be coming in contact with the hazardous waste. For importing hazardous waste, importing in the sense from the point of generation till the point of disposal. For importing hazardous waste, leveling is extremely important. So what the level supposed to convey? What the level supposed to carry? The information. The information is what exactly is the waste characteristics, what is the flash point, whether it is ignitable or not. If the waste is accidentally spilled, then in that case, what are all the treatment technologies it's supposed to, what are all the treatments it's supposed to undergo? If the waste is consumed, then what are all the measures somebody is supposed to take? If the vehicle transporting the waste, if it undergoes any accident, then what measure it's supposed to follow? And who is the expert person who can give you solution about all this? Their name and mobile number. This is what it's supposed to actually carry. Okay. And regarding the safe storage and disposal of hazardous waste, it's extremely important to regularly inspect that the labeling is proper, storage is happening as per the protocol, different characteristics of waste, they're supposed to be stored differently. All are hazardous waste. If some waste is depicting ignitability and if some other waste is depicting toxicity, both are haz waste, but their criteria for meeting with haz waste is different. Based on that, this is supposed to be stored separately, and the storage guideline in detail I'll be talking about in forthcoming slides. So regarding the transportation of hazardous waste, these are the following norms that's supposed to be followed. Motor Vehicle Act 1988. Okay, that means the transporter who is carrying this haz waste, they must be having a valid license. The vehicle must be having valid insurance. The vehicle must be having a valid pollution certificate. All these things. Okay. Central Pollution Control Board (CPCB) guideline for haz waste transportation. Haz waste containers should be provided with level. As I told you earlier, leveling supposed to be done as per Form 12 of Haz Waste Management Guideline 2008 Central Pollution Control Board. And there will be a 6-form manifesto. As I told earlier, there are total 15 forms regarding hazardous waste. On the second slide I have mentioned, but out of those 15 forms, 6 forms are extremely crucial, as I told earlier, which are of different colors and which are connected mostly to the transportation as well as information sharing and disposal of hazardous waste. Okay, this particular methodology is terminated as TREM, Transport Emergency Card. Transport Emergency Card. It gives you the complete idea about what hazardous waste is being transported, how exactly in the case of accident it's supposed to be attended, what are all the on-site treatment or precautionary methods we need to take while handling this haz waste. And this is one of the actual example of TREM card, Transport Emergency Card. Okay. So these are the information it's supposed to carry: type of waste, physical property of the waste, chemical constituents, Exposure hazard. Exposure means if you are exposed to, if there is no barrier between you and the waste, then in that case, what are all the exposure hazards? If you inhale it, what is the hazard that you're going to face? What is the first aid requirement if you get exposed? Then what are the first aid procedures you need to follow? Procedures to be followed in case of fire. If the vehicle catches fire, then what are all the procedures supposed to be followed? Okay. Procedure to be followed in case of spillage, accident, or explosion. For expert services, please contact the name, number, and telephone address and telephone number, as I told earlier, right? So these are the information a typical tram card for hazardous waste supposed to follow. Hazardous waste leveling. As I told earlier, at the point of generation, leveling of hazardous waste is extremely crucial. I mentioned earlier, right? So this kind of yellow cards, the color for haz waste is yellow. And this kind of black and yellow card supposed to be affixed on the drum it is being stored. Whether it's HDP or steel drum, irrespective of that fact, this card supposed to be affixed on it. So what is the waste category number under Schedule 3? As under Schedule 3, under Schedule 1, or all things we have identified, there are 36 different industrial processes which are categorized under hazardous operation. Schedule 2, what it talks about? Concentration. Schedule 3, what it talks about? Different characteristics, different categories. So under Schedule 3, we need to write down what category it is under. What is the total quantity in terms of ton or kg? Okay. Constituent and state of the waste. State in the sense whether it's in solid form or whether it's in liquid form. And sender's name and address. Sender means who is the generator. Their phone number, telephone number, contact person detail, and all these things. Okay. And here, if you see on the right hand side, date of storage. Okay. Date of storage mean at what date it was produced and what date it was stored. And here you need to provide the information of the TSDF operator, treatment, storage, and disposal facility operator, their name, phone number, telephone, contact detail, and all these things. So as I told earlier, there are 6 categories which are very crucial. Out of those 15 forms, 6 forms are crucial. So the first form, color coding, is white. So this is to be forwarded to the State Pollution Control Board or Pollution Control Committee by the occupier. Occupier means the waste generator here. So form 1 in white color supposed to be sent to the local or state pollution control board, which carries all the information about the waste, where it's supposed to be treated, how it's supposed to be disposed, and all this information. Copy number 2, which is typically yellow in color, form 2, to be signed by the transporter and returned back to the occupier. So transporter, let's say you have a third party transport who is transporting your hazardous waste from your point of generation to waste disposal point. Okay. So can anybody please unmute and convey? Am I audible? Any faculty coordinators?
Yeah, sir, you are audible. You can go
Right.
forward.
Thank you. Right. So let's say I am generating somewhere near, I have a facility near Golconda Fort, near to your institute. Okay. And I'm generating hazardous waste there. And my hazardous waste treatment facility is in Dundigal, which is typically the case for Hyderabad. Okay. So in that case, I need to transport hazardous waste from Kokapet to, let's say your institute is in Kokapet, from Kokapet to Dundigal. So somebody, I have engaged a third party transporter for transporting waste from Kokapet to Dundigal. So form number 3, which is typically pink in color, it's supposed to be retained by the operator of the facility. That means if you're the generator, you're supposed to keep pink color form. Now coming to form number 4, which is orange in color, to be returned to the transporter by the operator of the facility after accepting the waste. So that means now it came to the TSDF facility at Dundigal. Operator means TSDF. So this form, it's supposed to be given to the transporter. That transporter has actually given the waste, brought the waste to the TSDF facility. This is the proof of that. Okay. Then there's a green color form, which to be forwarded by the operated to the State Pollution Control Board. So this includes again the same information. So this form white and form number 5 green, both are typically same. This is forwarded by the waste generator to the Pollution Control Board. This is forwarded by the waste treatment service provider to the Pollution Control Board, and both the information supposed to match. Okay. Coming to point number 6, which is copy 6 or form 6, which is blue in color. That has to be, this is post-treatment and disposal. So the operator or the service provider or the TSDF facility, which is located in Dundigal, after treatment and disposal, they will generate this slip and they will send it back to the waste generator at Kokapet. Okay, that your waste, whatever you have sent, it is scientifically handled, treated and disposed of properly. Now, under EPR, extended producer responsibility, whatever waste you have generated, you have treated the same amount of waste. So your liability is finished. Okay. What is the transport guideline now? First of all, you need to obtain permission. So whatever the vehicle you are going to use for hazardous waste transportation, these vehicles, they have to be completely closed body vehicles. They should not be open like high tippers or long trucks. They have to have a closed body. Okay. Second, all the vehicles whatsoever you are utilizing in hazardous waste transport, all the chassis number, the insurance certificate, the pollution control certificate, the registration number, everything, all the information has to be there with the State Pollution Control Board. You have to submit all the information to the State Pollution Control Board, whatever the vehicle engaged into this operation, the transportation of hazardous waste from point A to point B. And then after that, what you need to do is periodically, every 6 months, there will be a review by Pollution Control Board and you have to update this information. Okay. Transport in closed and suitable containers, as I told earlier. Deployment of dedicated leak-proof trucks. That means if you are carrying any sludge, let's say Hyderabad is a hub of pharmaceutical industries, right? So from this pharmaceutical industries, for production of drug, they need water. But during this production, if I'm consuming 100 liter of water, 80 liter gets transformed into wastewater. And this wastewater also carries solid waste in it. The solid waste percentage typically varies between 2 to 5%. So what happens to that solid waste? It gets actually converted into sludge after wastewater treatment in effluent treatment plant. And this sludge is again hazardous in nature because of the presence of heavy metals, BTX and other compounds, micromolecules, surfactants and all these things. So this sludge, it has a moisture content somewhere around 50 to 70%. So automatically leak-proof containers are required for transporting this sludge from ETPs of pharmaceutical industries to TSDFs. Okay, so that this, because of this excessive moisture content, leachate should not be oozing out from the body of the container. And if this leachate drops up and goes and mix into the groundwater, automatically it has a potential to contaminate. One drop of leachate can contaminate hundreds of liters of groundwater. Okay. And the drivers and helpers who are all working, they have to be trained for TREM. TREM is transport emergency. TREM card I told earlier, right? So transport emergency means if there is an accident, if there is a spillage, if there is any leakage, if there is any fire, or if there is any explosion, this driver and helper, they need to know what are all the precautions to be taken, what are all the basic treatment, suppressing method that they're supposed to follow, and whom to contact in that case, who is the expert to be contacted. So this is how typically a hazardous waste transport truck looks like. This should be blue in color. So you can see the truck body is blue in color, and the truck engine is blue in color, engine compartment, and the body is yellow in color. Leak-proof container completely, standing on the weighbridge. So the weighing is very crucial because you need to know the quantity. As I told earlier in one of the forms, quantity has to be updated on a daily basis to State Pollution Control Board, and once in a year that has to be updated to the Central Pollution Control Board. So that is why weighing of the waste is extremely important. So what we do is we take the total weight of the waste with total weight of the vehicle and the waste. Then the vehicle goes to the temporary storage unit. There the vehicle gets emptied, and after washing of the vehicle, washing of the tires, the washed vehicle, it goes back to the same weighbridge once again. So we know the total weight, which is the combination of the weight of the waste as well as weight of the vehicle minus weight of the vehicle. So we get to know what is the weight of the waste. Before the vehicle goes to the temporary storage facility, what we do? We go and we collect samples from the vehicle. This is a sample collection bay, and from this area we collect a sample for a fingerprint analysis, which includes analysis such as pH, physical, texture and color, odor, paint filter liquid test, okay, ignitability, flash point, okay. All these parameter values we test and we check it against the comprehensive analysis value. Initially, at the very initial stage, when we have done comprehensive analysis, which included some 100-150 parameters, against those values, we check these values once again to reassure the waste characteristic remain the same. If the values are not matching, once again we need to do re-comprehensive analysis, and once again we have to derive the disposal pathway accordingly. So these are the different fingerprint analysis parameters that we check: loss on drying, loss on ignition, PFLT, LRT, liquid release test, pH, reactive cyanide, reacting sulfide, all these things. So here you can see this is a real photograph from Dundigal, Hyderabad, the TSDF facility where I worked for about a year. Fingerprint analysis is going on. Waste acceptance criteria, different concentration of different parameters, okay, against fingerprint analysis are depicted here in this table. This is very crucial. So hazardous waste, whether it's permanent storage or long-term storage versus temporary or short-term storage, both are extremely crucial because of the nature of the waste. So this is how typically a haz waste storage unit looks like. This is called PEB, pre-engineered building. So bottom should be an impervious concrete floor of minimum 8 inches thickness, and from the MSL level, mean sea level or mean flood level, it should be minimum 150 mm high. From mean flood level, it should be minimum 150 mm higher, okay. And there should be a clear space for vehicle movement, and then between hazardous waste barrels or drums, they are stacked with the help of pallets one after the other vertically, and there should be a clear space of minimum 15 meter between two pallets. I'll just show you actually, in fact, instead of saying, yes. So these are called pallets, wooden pallets. On top of each barrel, we place one wooden pallet, and then the other barrel actually comes in, and the space between these two, between two pallets, is minimum 4 meters here, okay, and 15 meter is required. This space is 15 meters or about 50 feet for vehicle movement, easy vehicle movement. And in each stacking, it should not be exceeding 300 metric tons of haz waste. The combined waste quantity of waste, the weight of the waste should not be exceeding 300 metric ton. You can see the firefighting system here. These are fire hydrants, the output of water sprinkling system. This is fire alarm. This is water sprinkling system. This is fire hydrants for high pressure and high quantity, again from the same facility. The pictures are from the same facility. Time to time, this inspection every 3 months. Every quarter there is an inspection of these fire hydrants, whether they are functioning properly at proper pressure or not. Okay. I think already I've talked enough about all these guidelines. Yeah, this is very important. So hazardous waste, if the liquid content is higher, okay, and if these barrels, they are leaking automatically, or if there's a spillage, automatically leachate supposed to come out, and this leachate, hazardous waste leachate or inorganic leachate, it is highly toxic in nature, extremely toxic in nature. So what we do is we put a drain called garland drain. That means it's a depression across the storage unit. I showed this storage unit earlier, right? So this here, there's a garland drain starting from this. There's a depression you guys can see. So this is the garland drain, which covers almost 360 degrees except for the vehicle movement area. Almost 360 degrees it covers. So if there is a leachate generation, this is an impervious drain, completely concrete sealed impervious RCC drain, reinforced cement concrete drain. and it ensures that zero liquid discharge into the groundwater, and entire liquid collected through these drains, it goes to a collection sump, and from there it goes to leachate treatment plant. This collection sump also, if you see, it is lined with HDP liner, high density polyethylene or geotextile liners. So it ensures zero leachability, zero percolation from that. Okay. So under disposal pathway, at the beginning, I told there are 4 different categories. Either it is direct landfillable waste. That means without any treatment, the waste can be directly sent to the landfill. For an example, waste like organic sludge, which is typically from pharmaceutical industry, inorganic sludge. Okay. Then landfill after treatment. Let's say any waste like salt. There is humongous amount of spent salt we receive in Hyderabad. So salts are typically used in medicine manufacturing, right? Like magnesium chloride, magnesium sulfate, sodium chloride, potassium chloride, sodium, potassium, magnesium, different chloride and sulfate salts, basically. So these salts, once they're utilized in the medicine manufacturing process, they get converted into spent salt, which is typically waste salt. So this waste salt, they're hygrophilic in nature. That means they will capture moisture from the atmosphere and they will get reconverted into leachate. They will actually start oozing out alongside leachate. So this salts, first of all, we have to stabilize, we have to solidify with the help of lime and fly ash and other stabilization mechanism, then only it can be disposed of into the landfill. So this is called landfill after treatment, and the treatment supposed to be determined based on the fingerprint analysis. Coming to the third part, waste, I told calorific value as assessment of calorific value in fingerprint analysis is very, very important. And for that, we use bomb calorimeter. So once the calorific value of the waste is more than 3000 kilocalorie per kg or calorie per gram, it will go under incineration or landfill or AFR, alternate fuel and raw material. Okay. Incineration means it will be burnt off at a temperature of 900 to 700 degrees Celsius. Almost 1/10 of volume reduction will be achieved. That means if I'm introducing 100 cubic meter of waste, only 100 cubic meter of bottom ash will be there. Bottom ash and fly ash will be there after burning. Okay, that is the typical residue. And then the remaining will be converted into vapor. And this vapor has to be treated thoroughly. For that, we need to have a treatment of series of treatment scheme. I'll discuss about those things as well. So this is how typically a secured landfill looks like. So the bottom layer is nothing but liner layer. So there, any secured landfill, it's a double liner system. That means I'll put a liner. Let's say I'll go with clay liner. Then on top of it, I'll lay geotextile, geonet. Then on top of that, drainage collection, leachate media. Then coarse aggregate and fine aggregate. And then the same thing I'll repeat once again. So that is why it's a double liner system, because the waste characteristics is extremely toxic in nature. The waste is hazardous in nature. That is why I am giving double liner. For municipal solid waste landfills, it is a single liner system. For hazardous waste landfill, it's a double liner system. Okay, so that no leachate should actually ooze out. No leachate should penetrate the liner. Okay, no sharp object should penetrate the liner. And this is the leachate collection system, leachate collection drain, and it comes to the leachate collection pit. From that, it goes to spray dryer, leachate treatment facility. And then there is gas collection system. Typically for haz waste, the gas generation is extremely negligible. This gas collection system is connected to a gas flaring system. That means whatever the gas is generated, it will be burnt off. Whatever the trivial quantity of gas will be generated, it will be burnt off. So nothing actually goes and get mixed with the atmosphere. Okay. And then once the waste is actually filled in here, there is again one more layer of liner on the top as well, so that rainwater should not percolate or anybody should not come in contact with it. Okay. So landfill liner, what are the different kind of liners we are having? So the base liner system. So the base liner is nothing but clay liner. Okay. Geosynthetic clay liner, GCL. Leak detection system. Leak detection system in the sense leachate should not be penetrating and mixing into the groundwater. So that is why this leak detection system is crucial. Leachate collection system. We are keeping, perforated HDP pipes filled with filtration media, which typically includes coarse and fine aggregate. So that is leachate collection system. It actually filters out all the heavy size particles and the inorganic leachate, which is typically liquid in nature, that actually goes and gets collected into leachate collection pit. From there, it goes to leachate treatment plant, which is typically a spray dryer. Okay. Gas collection system and gas venting system. So as I told earlier, whatever the minor or trivial quantity of gas is being generated, it is burnt off. Okay, it is simply ignited up or flared up. So that system is called gas flaring system. And top cover system. So once the landfill is completely full, let's say the landfill capacity is 20,000 metric ton. So once you finish disposing of 20,000 metric tons of waste, then the top cover will be produced and the landfill will be closed. Same liner, whatever you have used in the bottom, same liner will be used at the top. On top of it, you will include a vegetative layer. Vegetative layer means it's a soil layer. On top of it, you will do vegetation. So in vegetation, what are all the things? It includes small plants, shrubs, which does not have a root length more than 1 meter. Those species we choose. Okay. If I try to explain that with the help of illustration, it is here. So layer number 1, you can see this is GCL, geosynthetic clay liner. On top of it, this is HDP liner, which is typically the geotextile liner. On top of it, this blue color one, what you're seeing here is a geo mesh or geo net. And then again, clay liner, as I told, double liner system, right? Again, another clay liner, again, another geo net. Again, why geonet is important in between? Because HDP liner or geotextile liner, it is just like plastic. So there's a very high possibility that it might actually, lose the grip. So that is why geonet is important, to provide grip to geotextile liner. And then on top of it, again, another layer so that again it can produce grip. And then the filtration media is supposed to come, the leachate collection system supposed to come, aggregate supposed to come, and then I'll start disposing of the waste here. And then again, another rubble layer, synthetic clay liner, again, another layer of geonet, then again, another layer of geotextile, okay, which is typically HDP liner, then vegetative soil, and then on top of it, vegetation. This is the landfill excavation. So typically for haz waste, we use a combined landfill method, which includes underground and over the ground landfill. So you guys can see excavation is going on, and typically landfill is excavated in trapezoidal shape. Like this is the ground level, let's say for an example. So it will fall off like this. For slope stability, we use a trapezoidal shape. These are the real photographs from Hyderabad. Clay, this is the GCL liner, geosynthetic clay liner after trapezoidal shape. As I told you earlier, trapezoidal shape. For slope stability, 1:2 slope ratio. That means one vertical versus 2 horizontal. Okay. And then you can see this is the geotextile membrane, HDP liner, and these tires are laid off so that they should actually retain on their position. They should not be sliding off. Here you can see on top of the geotextile membrane, coarse and fine aggregate is laced. First coarse aggregate followed by on top of it fine aggregate, and this laterals, what you are seeing here, this is nothing but the leachate collection drains. Okay, this is supposed to collect the leachate that is being generated from the waste. Okay, now this landfill is ready for waste disposal. Waste disposal is being carried out with the help of a dumper placer. Okay, this inside this bin, waste is there, stabilized waste is there. Okay, and after waste is disposed, you can see with the help of an excavator, the waste is spread and then it is actually compacted. Daily soil cover. Now, this is a very important phenomenon. Hazardous waste, as we know that it is highly hazardous in nature, it should not be coming in contact with the open atmosphere. So on a daily basis, whatever the waste is actually filled into the landfill cells, it is covered with soil. At least 200 mm thickness soil we use and we cover it up, entire waste. Okay, so that thing is called daily soil cover. After even daily soil cover, during monsoon, we make sure that another layer of HDP liner or geotextile liner is laid on top of it. Okay, and nothing penetrates inside. Okay, so that is why this is showcased here as monsoon planning. So this is landfill under capping. You can see already soil cover is provided, and now we have to actually give top cover layer, and then we need to do vegetation. And this is the capped landfill. This portion is the capped landfill. This is how typically a capped landfill looks like. This is the gas vents. Okay. This is how typically a hazardous waste collection and transportation vehicle looks like. And as I told earlier, the vehicle, once it empties, the load is emptied, then the vehicle body will be washed, tires will be washed, and the wash water will be mixed with the leachate and they will be treated alongside. So here you can see vehicle washing is going on. It is in progress. Leachate disposal standards. I'll not go into so much of intricate details. So this is how the leachate treatment actually looks like. So this is what the leachate treatment collection tank is. Sorry, leachate collection tank. This is how it looks like, a lined HDP lined pond, so that nothing should penetrate into the groundwater. At the same time, it is exposed to the atmosphere so that because of the evaporation, some volume can be reduced and there will be less burden on my mechanical evaporation scheme. So in the mechanical evaporation scheme, what we do is a spray dryer. It sprays the leachate in the form of a very thin sheet or thin film, and then the temperature within a closed conduit vessel where the pressure is very high and the temperature is maintained somewhere around 120 degrees Celsius. Because of that, water present in the leachate starts evaporating. So water evaporates, and through a condensation mechanism, we recondensate the water and we start recovering 70 to 80% water out of leachate. And solid comes out from the bottom. Whatever the solid was there, solid starts coming out. We call it concentrate. And the water that we recover, we call it condensate. Condensate and concentrate. So this solid, once again, this solid or concentrate, it goes to the secured landfill. And the condensate, it's a pure water. It can be reutilized within the same premises for greenbelt maintenance, for makeup water, for leachate treatment, for vehicle washing, for this kind of ancillary activities. Okay. This is how typically a waste stabilization bins looks like. So once the vehicle goes to the temporary storage facility, thereafter the lab does the fingerprint analysis, lab releases the treatment pathway. So lab gives you a note where the treatment pathway is actually provided. Based on that, the vehicle is emptied in the stabilization bins. We mix different kind of reagents, and with the help of a backhoe loader, we actually mix everything. And then once the mixture is actually solidified, then it is loaded into HDP containers or concrete containers, and it is sent to the landfill. Further, for incineration purpose, once the incineration waste is incinerated for INCIN category of waste, we need to treat the vapor also from burning, whatever the vapor is being generated, whatever the flue gas we call it. In technical term, we call it flue gas. Whatever the flue gas is being generated, we have to treat that. So the first treatment scheme is a spray dryer. The spray dryer is a wet scrubbing system. Okay, in that we take out all the acid forming gases like SOx, NOx, some amount of particulate matter. Okay, in spray dryer we use a mix of lime and milk and water. Okay, from that it goes to a cyclone separator. In cyclone separator, we further reduce the concentration of particulate matter, both PM 2.5 and PM 10, and then it goes to a baghouse filter. Baghouse filter is known for removing 100% of particulate matter, typically PM 2.5. Okay, and from baghouse filter, it goes to a superheater. From superheater, with the help of the temperature increases, right? Superheater means it will heat up the flue gas. It will heat up the gas parcel. So because of heating, what will happen? Whatever the volatile organic compounds are there, they will get oxidized. So VOCs actually causes odor. So VOCs are oxidized, VOCs are removed, and heavy metals are also oxidized in parallel to that because of the superheater. And superheater, what happens because of the heating, gas parcel actually increases in volume. The temperature increases, it increases in volume, it becomes lighter. And through booster Heidi fan, we give a very high draft. And with the help of this chimney or stack, minimum height is 30 meters. Okay. With the help of this chimney or stack, it is released into the upper atmosphere so that the plume should not be affecting the local environment. Okay. Because it is hot, it will start actually moving upward until unless because of the adiabatic lapse rate, it will exchange temperature with the atmosphere and it gets stable. So that it actually, get dispersed up into a height of somewhere around 1 to 1.5 kilometers range. Okay. typically at the end of stratosphere. So this is how typically an incinerator plant looks like. So here my rotary kiln is present. From that it goes to this baghouse filters and eventually all other filters, scrubbers, and then through this stack or chimney, the plume actually comes out. These are the different emission standard which is approved by Central Pollution Control Board. And this stack or chimney, there is a system called CEMS, Continuous Emission Monitoring System. So whatever the concentration of these parameters are on real time because of the probes or sensors, it will be displayed into your computers, and the same data will be actually given as a feed to local pollution control board as well as Central Pollution Control Board. So if you don't match this concentration, automatically your project will actually undergo shutdown, and there will be humongous quantity of penalty levied on you. For an example, for particulates, it is 50 milligram per normal cubic meter. For HCl, again, it is 50 milligram per normal cubic meter, and so on and so forth. Okay. Thank you so much, everybody, for your patience listening. I guess I have presented for about 1 hour and 35 minutes. Now I would like to take about 15 minutes of time for addressing all the queries. I'm open to the forum for any question.
Hello, Professor.
Yes, please. Actually, the participants, they have raised their hands. So whoever has raised their hands, they can unmute themselves one after the other, and then they can ask their doubts.
Sir, we are only allowing to chat because of the size of the meeting. So I
Okay.
request you can go on the chat and clarify doubts, because if mic on, we may get some disturbance due to the large audience.
Got your point. Got your point. As of now, in chat box, I cannot see
Check
anything.
the chat box for the questions.
I
Now
cannot
can-
see anything in the chat box, actually. It is empty. That's what I'm seeing.
All participants, you are requested to post your any questions
Queries
in
in the
the,
chat box.
what do you say, in the chat box, so that the speakers can answer.
One more thing, which is very, very crucial, is that for any TSDF facility, if you want to establish a facility, it should not be within 75
Okay.
kilometers radius of any existing facility. That means Central Pollution Control Board, they have actually kept a norm. If you are trying
Hello,
to
participants. Don't raise your hand. Just go into the chat box and post your query here. Yes.
The attendance, it will be
Sir.
after second session. Just we are asking about the questions, please.
So 75 kilometers radius.
Questions
Same.
regarding this session, please request you to interact with the resource person and utilize this opportunity.
So as I was trying to convey, for both common biomedical waste, which is again hazardous in nature, as well as industrial hazardous waste, if you are trying to establish a facility as per the Central Pollution Control Board norm, within 75 kilometers radius, there should not be any other same facility. Okay. That's a very important point from the guideline perspective.
Hello, Professor. Questions are in chat box.
Yes, people, they have started posting. Yeah, I've started seeing Dr. Rachna. Thank you, sir, for informative session. Vijay Anand, thank you, sir. Good evening, sir. Thank you, sir. It was nice session on hazardous waste management. Everybody is most welcome. Thank you. Thank you so much for your kind feedbacks. Can we use catalytic converter in vehicles? In vehicles already, people, they use catalytic converter. All our vehicles are equipped with catalytic converters. It is typically in the exhaust pipe. How much does it cost? Okay, the cost varies. For bike, if I try to give you an example, for two-wheelers, catalytic converter that is present because it possesses precious earth metals like palladium, rubidium, platinum, gold, copper. So because of that, this catalytic converter which is present into the silencer pipe, it costs somewhere for bike between 10 to 12,000 rupees. Catalytic converters are not very common in industrial scale. For for stacks or chimney, what we use is, am I audible, guys?
Yes, sir. You are audible. You can go
Yes,
ahead.
for stack or chimneys, a similar kind of product, what we use is electrostatic precipitator, not catalytic converter, electrostatic precipitator. What is it? So I have positively and negatively charged plates placed on the stack or chimney. So any particle, any charged particle, whatever had escaped the route of cyclone separator or scrubber or baghouse filter, what will happen? They will have charge, right? And I have positively and negatively charged plates in the chimney. So negative charge will get attracted to positive and vice versa, and they will get stuck to the surface. So once my process is over, once the batch operation is over, what I'll do is I will actually turn off the electrostatic precipitator, and whatever actually was stuck to the surface of the precipitator, they will fall off. Because of the exchange of the charge, they will get neutralized. And because of that, it will fall off at the bottom of the chimney. From that, we can actually scrap it and clear it off. We call it industrial fly ash, as simple as that. Okay.
Yes, sir. One more question. What we got here is, sir, can you give any examples of 5 hazardous waste materials?
Can we use catalytic converter? Done. Feedback link, please. Attendance links. Very informative session. Thank you. Thank you. For proper operation of incineration. Incineration spelling is wrong, by the way. Incineration plant. Primary combustion and secondary combustion need to maintain what temperature for combustion, sir? Okay. Primary combustion chamber temperature should be 400 to 600 degrees Celsius. Secondary combustion chamber temperature should be 900 to 1100 degrees Celsius. Okay. 400 to 600 degrees Celsius, 900 to 1100 degrees Celsius. Hello, sir. Is there any way we can use hazardous waste in concrete production? Will it be safe for mass production? Yes, we can use, not hazardous waste to be precise, but what we can do is leachate. We have already done some case studies in our Mumbai facility when I was in Ramki. So leachate actually can be utilized as a replacement or partial replacement of water in concrete making. So we have prepared, fly ash bricks with leachate, as well as concrete block with leachate as a partial replacement of water, which typically ranges from 20 to 30% replacement of the actual water requirement. And with the help of some special binders, we entrapped the heavy metal percentage in the leachate so that there was no leachability. Okay. And in fact, we constructed a compound wall with the help of those fly ash bricks in Mumbai, in our MWML facility. So yes, leachate can be utilized, and also up to a certain extent, this is under research and development phase right now. Up to a certain extent, this ETP sludge from pharmaceutical industries or steel industries, they have a property of non-dissolvability. They're insoluble in water up to a certain extent. So you need to find out after drying this ETP sludges, what is their solvability and what is their dissolvability and how much insoluble they are. Based on that, you can use them as a partial replacement of sand in concrete making. Again, subjected to lot of research and development, what kind of TCLP characteristic it will show, what kind of WL2 characteristic it's supposed to show, how much percentage of replacement you can actually go with, how it is affecting the compressive strength and tensile strength. There are many factors to be considered. It will be safe in terms of safety perspective. It will be safe until unless, as long as it is mechanized completely. There should be zero human intervention. If you are doing it thoroughly with the help of machines, it is safe. There are a lot of Thanksgiving I'm seeing after that. Is there any other question? Share the PPT. Okay, fine. I'll share the PPT with the faculty coordinator. He can further share with you guys. Give an example of 5 hazardous waste materials. Okay. I'll start with domestic hazardous waste. That's the newest inclusion in hazardous waste category. First is tube lights and CFL bulbs. Number 2, any kind of paint or paint sludge. Okay. Number 3, any thinners. Okay. Any chemicals and expired drugs. Expired drugs in the sense medicines. Number 4, any nail pens, any ointments, any medicines which are expired. And from industries, if I typically talk about waste from packaging industry such as thermocol, polyurethane foam, extended polyethylene foam. Okay. Waste from pharmaceutical industry, all categories of waste from pharmaceutical industry. Waste from dyeing industry, typically dye manufacturing industry, which are typically placed in Coimbatore in India. Waste from paint industries. Okay, these are the typical examples. Waste from chemical manufacturing industries. For an example, Sipcot in Tamil Nadu, in Chennai, in Kadlur. Waste from any kind of electroplating industry, like galvanizing. Their chromium and zinc, nickel, these levels are extremely high in you consumed water. So any electroplating industry, any mining industry, okay, like mineral mining, waste from mining industry. These are the typical examples of hazardous industrial waste. So there are 36 operations under Section A. I told you earlier, there are 36 operations which are identified under hazardous waste operation. Out of those 36, I've given you few examples, right? What may be the least particle size collected using electrostatic precipitator? Now, this is a very difficult question to answer. It might be a few nanometer. Okay, the particle size might be a few nanometer, but there is no specific literature available in order to conclude on that, because they are extremely small. And this piece of information is generally not very informative, because there are guidelines by the Pollution Control Board which states that you should not be exceeding this particular range, right? So nobody is bothered until unless they are not exceeding that range. Nobody is bothered about studying the particle size. What are the requirements for landfill waste? Okay, so landfillable waste are the least, the waste with the least level of toxicity in haz waste. They are called direct landfillable waste. Waste with higher level of toxicity, higher moisture content, they are landfill after treatment category. And waste which are not having calorific value. If the waste has good calorific value or heating value, it cannot be and should not be landfilled. The fundamental criteria is waste should not be having calorific value, followed by further distinguish further whether it should be LAT or DLF. It depends on different types of fingerprint analysis.
Hello, sir.
Yes, please, sir.
Hello. Sorry for interrupting, sir. Sir, next speaker is in online, sir. Just we are checking out whether the mic is audible or not. Hello, Mallikarjuna Rao, sir.
Hello, brother Mallikarjuna. You.
Hello, Mallikarjuna Rao, sir. Am I audible?
Yes, sir. Yes, sir.
Okay.
Hello, Professor Rao. How are you?
Yeah, fine, sir. Fine, sir. How are you, sir?
Coincidentally, we are delivering one after the other.
Yes,
right.
Sir. Yes, sir. Yes, sir.
Right. I'm good. I'm in Nashik right now.
Okay.
I have been invited by government of Maharashtra. Sorry?
Sir, just a minute. Just the speaker session 1 question answer is going on. Just we are taking welcoming you for this on the session. Just we will start in next 10 minutes. Till that the session 1 speaker will be taking over the question.
Okay, sir. Okay.
Yes. Okay. Just check your mic and other things, sir. If everything is fine, or else our team will support you in that case.
Is there an
everything
active
is fine, sir.
Yes.
Yeah.
I'll not take more
thank
than
you,
5 minutes.
Thank you. Just be
more
online.
questions.
Yeah. Yes, sir. You can go on. You have the 10 minutes to session, sir. Please, you can
Yeah,
go to the
right.
questions which are important.
Actually, I'm in Maharashtra. I've been delivering 2 more sessions back to back just today post lunch. So my voice is almost about to get choked. So somehow still, because of the previous promise that I've been, Professor Jalal knows about it. So yeah, if there is an accident while transporting, what are the way of handling it? That depends on magnitude of accident. If there is fire, definitely we require foaming agents. So hazardous waste, mostly it is, if it is like if the CV is more than 3,500, then automatically it will be ignitable, inflammable. There, it might be carrying those properties, right? So foaming and rapidly expanding agents are required in order to cut off the oxygen supply. Okay, and waste to waste it will vary. If it is like wet sludge, automatically it has to be contained, and immediately we need to see how we can restrict the leachate flow into the groundwater, or it should not be contaminating the ground. We have to construct channels and we have to collect the leachate somewhere. So it varies, waste to waste it varies. Okay, there is no hard and fast answer to this question. It has to be customized based on the quality of waste. Good evening, sir. Very nice session presentation. My question: if we use bamboo ash, is it possible for making concrete? Okay, so bamboo ash for concrete making. Bamboo ash is a pure carbon. Okay, because bamboo ash is a category of biomass. When you burn it, it gets transformed into pure carbon, and bamboo ash is typically utilized when it is burnt at 400 degrees Celsius temperature. It is utilized as activated carbon or char, which has a higher commercial value. Okay, because activated carbon is used as a filtration media for absorbing color from wastewater, for absorbing VOCs from wastewater, for absorbing heavy metal from wastewater. So it has more commercial value than rather than using it for concrete making. Point number one. Point number two is, for concrete making in ash, you require two properties. One is presence of SiO2. The other one is presence of Al2O3. If these two are present, then only it will be giving you the binding property. Silicon is known for giving you binding property. We need to check for any fly ash if it has to offer good quality of binding strength. Al2O3 and SiO2 combined, minimum percentage should be 30%. So we need to check bamboo ash whether it is satisfying that 30% norm or not. If it is more than 30%, it will be actually depicting that adhesive property, and it can be used in concrete making. If not, it cannot be. And moreover, more than concrete making, it has a better commercial application in the market, which is as a charcoal. So therefore, I recommend it is better to be used as a charcoal. Okay. Plastic is hazardous waste. Depends. Plastic is non-hazardous in nature. Okay, if it is only plastic. But if plastic has been utilized as a packaging material for a hazardous waste, then yes. And there are some certain categories of plastic which are hazardous waste. For an example, thermocol. Thermocol is a kind of plastic which is hazardous waste because it is highly flammable in nature. Okay. EPF foam, that is also a kind of plastic which is again hazardous in nature. PU foam, again plastic, but again hazardous in nature. Somebody has asked, mentioning about few technologies regarding, inclusion in BE syllabus. Okay, fine. So for haz waste management, common technology is landfill. Common technology is incineration. Common technology is waste to fuel conversion, alternate fuel. Okay. For municipal solid waste, if you try to say, composting is a very common technology. Biomethanation or biogas generation is a common technology. Okay. Then you can talk about hydrothermal liquefaction, which is getting more popular these days, but not very common. You can talk about, leachate, different technologies for leachate treatment, such as spray dryers, mechanical evaporators, dissolved air flotation systems. You can talk about biological treatment schemes such as SBR, MBBR, MBR. You can talk about RO, ultrafiltration, micron filtration. You can talk about secured landfill and regular landfill, like sanitary landfill, single liner system. You can teach them about also, waste to energy schemes, RDF, refuse derived fuel, and incineration based waste to energy schemes. You can talk about pyrolysis, which converts plastic waste into alternate diesel fuel. You can talk about, you can also include, if it is about wastewater, you can include different kind of wastewater treatment scheme like sequential batch reactor, moving bed biofilm bioreactor, membrane bioreactors. Okay, these are the new and new age treatment technologies which are pretty common in the market. Okay. Hazards associated with solar waste. Yeah, that's a very crucial point. It's e-waste, basically, electronic waste. So electronic waste is a different segment altogether. There are dedicated facilities for tackling hazardous electronic waste. It does not come to TSDFs. Okay, e-waste facilities are completely different. So what do? Is they molten the solar panels first. They recovered plastic separately. After that, they solidify plastic. They recovered plastic separately, and whatever the rare earth metals are there, they recovered those separately, and whatever the other toxic compounds are there, they treat them separately, but that is taken care in the e-waste facility. Okay. What is your opinion about zero waste product making like char? It's a kind of controversial question. We cannot say anything as zero waste. There will be some fraction of it. For an example, even if we burn something, there will be bottom ash and fly ash. So that bottom ash, again, it's a kind of waste. Even with the help of RO, if we treat drinking water, RO converts regular water, tap water, into drinking water, potable water, right? So we cannot say that 100% treatment efficiency or efficacy is there. There is a concentrate which actually comes out as a reject from RO. So there is no treatment, in my opinion, which produces 100% byproduct and zero waste. So that's my conclusion. And with this was the last question that had been asked by Mr. Rahul. With this, I would like to conclude my session. Thank you so much once again for so many questions and appreciation. Thank you so much once again for your precious listening. I think this session had been a fruitful one, and you have learned something new today. Thank you one and all.
Hello. Hello. Thank you very much, sir.
You're welcome, Professor.
It was a wonderful session. Now the second session will be start. I would like to call Dr. G.Mallikarjuna Rao. He has a teaching experience of 6 years and research of 10 years, 5 months, and industry and others also. His specialization in structural engineering. Now he is working in a CBIT as an assistant professor. He published many international journals and national journals and has having patents. So, sir, Dr. Mallikarjuna, sir, do you hear me?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Now the second session will carry out you. The
Yes, sir. Okay, sir.
participants should maintain same attendance, and those who didn't pop up right now, they can join the session within 5 minutes for the second session. Okay, sir.
Now is it okay, sir?
Yeah.
Yeah. Okay,
Yes,
sir.
sir.
Good evening, sir. Thank you for inviting me as a speaker. So today my session is on eco-friendly construction materials. And before going to go with the eco-friendly construction materials, I'll go brief on about the sustainability. And whenever we are going to go for the construction, generally the concrete is going to play an important role. It's a very versatile material where we are going to use for the larger in construction aspect as a construction material. So why we are going to use this material as a main ingredient is where we can mold into any shape or any dimension, and what are the texture or aesthetic design we require. So based on that, we can utilize this material as a main ingredient. And one of the most commonly used material along with the cement, fine aggregate, coarse aggregate, and water, we are going to use this concrete as a man-made material there. And nowadays it was very popular. So generally whenever we are going to go for the preparation of the concrete, except cement, what are the ingredients like fine aggregate, coarse aggregate, water, and any other admixtures, that are locally available. So by using those ingredients, we are going to prepare our concrete for the required amount of the strength, workability, durability. We are going to maintain it. What are the properties? Like generally, whenever we are going to prepare any material, will means related to concrete, will we have to get three properties like workability, strength, as well as the durability there. So generally, these ingredients, whenever we are going to prepare our concrete, so cement, fine aggregate, coarse aggregate, in the total volume, almost 70 to 75% of the volume was occupied by your aggregate only, and remaining part will be with your cement as well as water and other admixtures in order to get good amount of the strength, good amount of workability there. And coming to these main ingredient is OPC, where we are going to take this material as an main ingredient in order to have the binding agent, and it will give certain amount of the strength there. In this one, generally means we have three different components there. One is calcareous, argillaceous material, and siliceous material. So calcareous material, generally it contains more amount of the calcium. Argillaceous material, it contains certain amount of the clay or the shale. So generally we take this both the ingredients and we'll heat up to 1450 degrees centigrade, and there would be chance for the formation of the clinkers. And clinkers, we are going to grind it into the fine powder, and there would there we are going to get the end product as an cement, which is going to play an important role in construction aspect. So these are the main steps where we are going to feed all the materials into the rotary kiln, and we are going to heat that materials where each individual step we are having preheating, we are going to do up to 650 degrees centigrade, where the separation of this lime as well as the carbon dioxide will be get separated. That process we'll call it as an, that reaction we'll call it as an calcining process, where these lime will react with the clay, and there would be chance for the formation of this clinker. Once the clinker was get cooled, we are going to add certain amount of gypsum, and end product we are going to grind it into fine powder, whatever the clinkers that are get formed, and finally we are going to get good amount means the cement as an end product there. So these are the certain amount of the process where we are going to consider our materials, where we are going to get your calcareous as well as the argillaceous materials from your earthen surface. We are going to consider those materials, and we are going to produce these construction material, that is nothing but your cement, where first it will go with the drying, after that the decomposition of these clay materials, then we had the calcining process, that calcium plus carbon dioxide, and end we are going to get our clinker formation at means 1450 degrees centigrade. And this is the black color. You can see that it was the clinker where it would get formulated, and we are going to get good amount of the strength. Generally, whenever you are going to take this OPC as an main ingredient, these oxide compositions are going to play an important role in order to contribute certain amount of the strength. Among all these things, the calcium is going to play an important role, where it is going to participate in your hydration reaction, and it is going to give good amount of the strength. See, all the materials cannot be as an cement, but we had certain amount of the oxide compositions like calcium, silica, alumina, iron oxide, magnesium oxide, and alkalis like K2O, Na2O, and sulfur trioxide. All these compositions where you are going to means give good amount of the strength there. And once these oxide composition or whatever the oxides we are going to supplement through our raw materials, where you are in the rotary kiln, we had the different series of the compounds that are already present, where it consists of four major box compounds that are nothing but trigalcium silicate, digalcium silicate, trigalcium aluminate, and tetracalcium aluminoferrite. So we had these percentage of mass where we are going to get means strength according to the age. At the initial stages, your trigalcium silicate is going to react, and later stages your digalcium silicate is going to react, and it is going to contribute the good amount of the strength there. And here the mass percentages, where your tricalcium silicate up to 50 to 70% by mass, where it is going to give 65% of the strength at the age of 7 days. See, later, after 28 days, we are going to get approximately 98% of the strength, where your oxide composite means the percentage of mass was approximately 15 to 30% there. So this tricalcium aluminate and tetracalcium aluminoferrite, they are not going to participate in hydration reaction, but definitely they are going to react very fast, and they are not going to contribute any strength whenever the cement, whenever you are adding it to with the water. So where you are going to get certain CHA gel plus calcium hydroxide there. And these are the compounds where these are present inside this clinker, C2S, C3A, C4AF, and these are the main ingredients that are going to contribute good amount of the strength. So once if you are going to get the strength, what reaction it would takes place, and how they are going to react, and what are the main stages that it is going to give you the good amount of the strength. The major compounds are nothing but your cement along with your hydration products. So the generally at initial stages that C3 hydration would be completed, later C3S, and after that we are going to get the good amount of the strength there. These hydration products generally C2S, C3S, C4AF. See, these are the means hydration reactions that are going to be takes place with your tricalcium silicate, where your amount of the heat that would be get liberated approximately 173.6 kilojoules, and tricalcium silicate it was approximately 58.6 kilojoules. So where your pore structure slowly it was get hydrated, and it is going to give you the good amount of the strength. So in this picture you can see that where you had certain unreacted particles, 30% of the reacted particles, and 70% of the reacted particles there. So where your red color indicates that tricalcium silicate, blue color indicates the dicalcium silicate, yellow color is completely gel formation, means where you're at the stage
Hello,
of
sir.
1 day. Sir.
Hello, sorry for interruption, sir. Sir,
Yeah.
you can change your slide from over your side only.
So slide is not changing, sir.
Sir, click on the second slide, sir. Because you are the host now, so you can change anytime. So that's why I told you to go for the slideshow. It will be easily.
Now
Yeah,
can you see?
yeah. It's fine now, sir.
Yeah.
You can carry on. Okay. Thank you.
Okay, sir. Okay. So where your hydration would takes place, and it is going to give you the means a good amount of the strength. Here the pores of your calcium silicate at the different stages, they are going to be changed with respect to hydration there. So the amount of the heat that would be liberated means it will be more for your tricalcium silicate and less for your dicalcium silicate there. So these are some of the particles where it is going to get reacted, and it is going to give you certain amount of the strength. For example, you had the cement particle that was get dispersed inside the water. We are going to have means 30% of the hydration. At later stages, you will have this means 70% of the hydration after 28 days. Means slowly the hydration process will continue, and it is going to give you the good amount of the strength. See here in this picture, you can see that some of the unreacted particles that are left out, and some of the capillary pores are there, where hexagonal crystals, portlandite, it is going to contribute means calcium hydroxide. It does not contribute the strength, but we have to reduce that calcium hydroxide through our materials. Means that is nothing but fly ash, GGBS, rice cash, metagolin. So those are going to react with that calcium hydroxide, and additional CHA gel formation would be there, and it is going to contribute the good amount of the strength. So here we can see certain amount of the volume where you had the fresh paste after 33% of the hydration, and slowly means the amount of the hydration it would get continued, and the products of unhydrated would be get reduced there. And here you can see the difference between, see, two water cement ratios we are considered. One is 0.5 and other one is 0.6, where your capillary cavities are there. Means here, based on your water cement ratio, the amount of the gel formation would be varied. and the amount of the strength contribution is also going to be get reduced through your high water cement ratio there. And coming to this microstructure, means whenever we are going to take any material that it is going to contribute the strength, we have to understand the behavior that by which compound you are going to get the strength there. So for the microstructure analysis at the different phases where your strength and durability means going to contribute the means that depends upon your amount of the pores that was get reduced, and whatever the water you are supplementing for your hydration process, that will leads to the amount of the strength generation there. So generally, if you consider your microstructure, so it consists of your aggregate phase, hydrated cement paste phase, and interfacial transition zone. Among all these things, interfacial transition zone is the weakest zone inside the concrete, where we had different types of the methods where you can consider these methods, and you can, by using these techniques, where you can study the microstructural aspect of your concrete. So generally means once this hydration was continued, we are going to get this calcium silicate hydrate gel, which was the main ingredient, where they are in the fibrous like structure. So means these irregular grains, where you are going to have this grains formation, that grains are nothing but means that are nothing but your calcium silicate hydrates, where your means these are going to contribute the good amount of the strength. So that names in the XRD analysis, generally we are going to represent in the terms of hortonite and laranite. So these two are the main ingredients where it is going to give you certain amount of the strength there. So the calcium hydroxide crystals, you can identify these crystal formation by whenever you are going to go for your microstructure aspect, where we had the plate like crystal means they are the size is also very small in the microns, where these type of the means crystals we have to means those are certain amount of the material that they are going to react with your sulfates, chlorides, carbonates, and it is going to reduce the strength of the concrete. So the much amount of the calcium hydroxide you are going to reduce, the more amount of the gel or the pore formation would be become very dense, and it is going to contribute the good amount of the strength. If you are going to consider your free lime or your portlandite, approximately 20 to 25% of the total hydration, there would be chance for the free lime that would be present. So these free lime means generally the volume was approximately 20 to 25%, where your portlandite means once you consider that they are going to contribute the less amount of the strength. So once if your strength or these portlandite would present, see it would be easily means react with your environment, whatever the harmful ingredients that were present, and then it leads to the corrosion of your environment also. So this is nothing but the calcium alumina silicate hydrate, where your ettringite formation would be there. So the ettringite are nothing but the crystals, where during early hydration you had some amount of the spaces there. Later stages, because of the densification, it will give you more amount of the strength. So here these are the some of the pictures you can observe, where ettringite, calcium hydroxide, and calcium silicate hydrate gel, these three are the main ingredients where it is going to contribute the amount of the strength. So coming to this aspect, where why we have to go for the eco-friendly materials or these building materials, the most of the means cases where the production of these particular amount of the cement was very high. Approximately 1 ton cement, if you produce 0.9 tons of the carbon dioxide will be get liberated into the atmosphere, where it accounts approximately 5 to 7% of the global carbon dioxide emissions there. See here, if you see, the largest producer of cement in the world is nothing but China. It is the first place, and second place goes to India. So where it contributes the high amount of the carbon dioxide emissions. So in order to reduce that, we have to go with the sustainability aspect, where we are going to utilize or natural materials, and we can reduce certain amount of the carbon dioxide emissions towards your atmosphere. So sustainability, where you are going to whatever the needs that was there for your means present generation, we are going to utilize all these things. So we have to meet all these means ability for your future generation, whatever they need. We have to maintain certain amount of the ecological health, as well as your whatever the environment that would be present, that we had certain amount of the threats there. One is nothing but your population growth, where year by year it is going to be get increased. And next one is nothing but your urbanization and globalization also. So because of that, lot of energy we are going to utilize for the production of the cement with respect to your construction aspect, and which leads to the global warming. And more amount of the waste that was get generated, that was dumped on the outside, where it is going to have the landfills, and they are going to pollute your air or water there. So the pollution we have to get reduced, and we had only the limited source. So year by year we are going to utilize a more and more amount of the material, that would leads to means the material would be get vanished. See, for example, in the production of your cement, we are going to use your calcareous material and argillaceous material. Those are also means year by year the cement production was getting increased. So because of this, there would be chance for the means that may become very limited resource in the future. So for that one, we had certain amount of the sustainable development goals, where we had 17 sustainable development goals. See, it covers all the things inside that, where it was a holistic approach. Means the development was the agenda. Main thing is that by 2030, whatever the United Nations member state in 2015, they had taken this blueprint of means your peace and prosperity of the people. And we they formulated the 17 sustainable development goals. So every country, they have to implement this. It may be developed country or developing country, which are the global partnership with each other. The main concentration towards your sustainable development goals is education and inequality, and we have to improve the health and climatic changes, all these things. And it covers a lot of things inside that sustainable development goals. So no poverty and zero hunger, and good health and well-being. It is going to cover gender equality, and we have to give the quality education to the people. And main important is clean water and sanitation, and affordable and clean energy. So this is nothing but where we are going to concentrate on these seventh sustainable development goals. And economic growth is also very, very important. Without disturbing the environment, you have to create certain amount of the revenue for the country. And we had certain amount of the innovations. So where, for example, you are going to have the battery vehicle, where we are reducing the usage of your fossil fuels, like that green energy. And we had the reduction of your inequalities among the country. And sustainable cities we have to develop, where we are going to use less amount of the material, and we are going to means implement that on the certain amount of the sustainability among the communities. That new concept, that green buildings, where it is going to have the all the natural type of the air or the water, all these things they are going to implement, that they are going to reduce the amount of the threat that was going to create for the planet there. And we have the responsible consumption. So we should not go for the high extent of the production. It may leads to the means vanish of the materials in the coming years. And climatic action, and life below the water, life on land, and peace, all these things, and partnership for the goals. So all these things are comes under these sustainable development goals. So once, before going to go for your eco-friendly materials, we had 3 different types of the carbons, where it is going to distract our environment: operational carbon, embodied carbon, and transportation carbon, where you had certain amount of the heating or cooling, or your elevators or electronic loads, whatever you're going to consume your electrical energy or thermal energy, that means how much amount of the operation that you are going to make, that will create certain amount of the carbon dioxide. These will means most obviously the more amount of the carbon dioxide emissions over the time is because of your operational carbon. So generally these operational carbon we have to analyze, and we have to utilize the less amount of energy, and either we are going to convert that wastewater into the useful, all these things, such that your operational carbon should be get reduced. And embodied carbon, where your materials are the products you are going to produce. For example, the cement is one of the major construction material. So we are going to extract the resources, and for that one, after that we are going to heat up to 1450 degrees centigrade. There the manufacturing of that particular products, and all these things, they means your materials, how we are going to produce that material, what amount of energy that was there, that building maintenance, or where you are going to go with the facility disposal, all these things will comes under your embodied carbon. And third will comes under the transportation carbon, where means you are going to create certain amount of carbon dioxide emissions through your transportation. So where we are going to consume a lot of fuel, which they are going to account towards your higher extent of your carbon dioxide. That may be related to your building, where you are going to get the material from the longer distances. Those are also going to create certain amount of the carbon dioxide levels into the atmosphere there. So once if you are going to means study about these three components, where you are going to have certain amount of the carbon footprint, your operational carbon, embodied carbon, and transportation carbon, divided by how much amount of the built up area that you are going to have, all these things will defines your carbon footprint there. So coming to the urbanization, where we had a lot of infrastructure development, where we are going to construct the high-rise structures for 20 floors or 30 floors, where means we are going to use more and more amount of your construction material like concrete as well as the steel. So these two are the main ingredients we are going to use for the construction aspect. So because of these more and more consumption, the great demand for these materials, so obviously these resources will be get depleted once if you are going to utilize these materials in the larger extent there. So that's why we have to go for our options, where we have to reduce, or we have to reuse that particular materials, or we are going to recycle that materials there. So generally how we are going to means reduce that. So once it should not be get disposal, and we can recycle that material. For example, recycled material was there. So after demolishing of the building, we can take that material and we can use inside the concrete, such that we can prevent certain amount of the means pollution that would be created on the environment there. So that's why whenever you are going to go for your sustainable technologies, so the main important is where we are going to use our supplementary cementitious materials, or your recycle or reuse of your concrete, where means once if you are going to enhance the life of the structure more, obviously the amount of the carbon dioxide levels or the amount of usage of these construction materials would be get reduced. That's why we have to go for the large extent of the research, where your usage of your emerging technologies will help you in order to means reduce your carbon dioxide levels or usage of these materials in the larger extent there. So whenever we are going to use for your materials for the construction aspect, generally we had certain amount of the process that we are going to follow, where your material cost should be very low, and energy which you are going to means use that for the production of that particular material should be very less. Means energy cost, where you require the fuels like coal, all these things, if you burn that one, then only you are going to heat up to 1450 degrees centigrade, and you'll get the end product there. So the energy cost also plays an important role while you are going to select your construction material as a main ingredient there. So you had certain amount of the means a high initial and final resistance should be very high, and the density also it should create on good amount of the compressive strength, not only just adding the waste material into the concrete that it will create certain amount of the strength there, but it has to reduce certain amount of the pores that was get generated inside through your hydration process or your calcium hydroxide means reduction, it will gives you the good amount of the strength there. And also the main important is that generally the workability, where the laborers work at the site condition, your working ability with that particular material should be very easy, and your pumpability also should be good. So the later stages you will go for your finishing part. All these three things should be get molded whenever you are going to take the ingredient for the construction aspect there. And one of the major important aspect is resistance towards your aggressive environments. So the more amount of the resistance towards aggressive environment means that material we can use for the severe or very severe conditions. According to IS 456-2000, the total environment was categorized into 5 different types: mild, moderate, severe, very severe, and extreme conditions, where you can utilize that material at that particular locations. So the permeability, where you had the ingress of your air or water into the concrete, where your voids should be get reduced. More amount of the reduction in the permeability, the better resistance that the material at your aggressive environments also. And one more important aspect is we had certain amount of the shrinkage cracks. So where your water would be get evaporated towards your atmosphere in the plastic condition, that may create certain, that may leads to certain amount of the volume changes, and it may formulate certain amount of the cracks on the surface of your concrete there. So that's why your shrinkage crack should be get reduced. And chemical resistance, obviously we have discussed about the durability point, where your sulfate resistance should be there, chloride, carbon dioxide, all these resistance would be there whenever you are going to process your material. So like that, we had certain amount of the sustainable construction materials, where you are going to have this fly ash, GGBS, slag, silica fume, and where you are going to consider your as an industrial byproducts. See, for this production of these products also we require certain energy, where the waste material that it gets generated from your steel industry or your thermal industry, where you are going to use this material and you are going to convert that waste material into the useful material there. One important aspect is that we are going to avoid certain amount of the disposal. So based on that, what amount of the things that you can mold or you can change in the total construction aspect, we can reduce the decrease the usage of the energy. So the less amount of the energy utilization would be there, and the greenhouse gas emission we can get reduced. And whatever the virgin materials that you are going to consider your calcareous or argillaceous materials, so less amount of the consumption of these virgin materials we can decrease. So later part it will formulate the secondary CH gel, where this gel will close the pores that was present inside the concrete, and they are going to improve your durability there. So fly ash, already everyone knows that approximately 600 million tons every year it was present, production would be happen in the worldwide. So now we are using approximately 10 to 15% inside the concrete. So in PPC also we can replace that with approximately 30%, 25 to 30%, where it will give you the better durability. And whatever the temperature changes that would be happen, means temperature rise, that would be get reduced through your fly ash. And these fly ash, the particle size was lesser compared to that of your cement particle, where it is going to means react with your calcium hydroxide. And again, these more amount of the quantum of silica that would be present inside your fly ash, that silica will react with your calcium hydroxide, and it is going to formulate your calcium silicate hydrate gel. So once if you are going to add this amount of the particle, that will react, and it is going to contribute the later stage strength. After 28 days, there would be chance for increase of your strength. So certain you can prepare your concretes with high performance or high volume fly ash concretes also, where you can replace your cement up to 50 to 60% there. And next other important ingredient is nothing but your blast furnace slag. So this is the slag where you are going to get from your steel industry, where your granules are approximately 25 million tons, where your cementitious material had increased in the recent years. It contains certain amount of the calcium, approximately 20 to 30% of the calcium would be present. And these calcium will react, and it is going to give you the good amount of the strength. For example, you had the blast furnace slag cement, where your blended slag cement, you can utilize this slag up to 50%. You can replace your virgin materials like calcareous and argillaceous, and you can replace with your 50% of the slag content. Next, other important is as a filler material. Generally, we are going to use the silica fume, where it is going to reduce your permeability of the concrete. Approximately the percentage of volume weight we are going to add inside the concrete is 8% by weight of the cement. That is the means optimal range where you can produce your high strength concrete greater than 60 MPa. You can utilize the silica fume, and alternative to some extent the replacement of your cement there. And by using this silica fume, you can have the better permeability. The flow of that water or air voids we can reduce up to certain extent, and your chemical resistance chemically it was more resistance towards that aggressive environments there. So if you use the high amount of the silica fume, see greater means 20%, 30%, it is very difficult to work. So there you can use your chemical admixtures in order to compensate your workability, strength, as well as the durability there. So now other important is the nanomaterial or the nanotechnology, where you are going to produce your materials in the nano size. Means generally the particle sizes will become very small, and where it is going to give you the better amount of the strength there. So this is about your nanomaterials inside the concrete. 1 minute, I'll share the other presentation. Sir, can you see my presentation, sir? Is the presentation?
Yeah, sir.
Yeah. So traditional concrete, already I had discussed that other construction material is nothing but your green concrete, where you are going to use this material as an eco-friendly. We are going to utilize our waste material and from different industry, where it requires less amount of energy, like fly ash, GGBS, rice ash, cash, metagolin. So whenever you are going to use this green concrete, where your amount of usage of your materials, regular construction materials, you are going to utilize less amount of the materials there. Because of that, there would be chance for the reduction of your carbon dioxide, and these materials are the cost would be very less, and it will create certain amount of the durability also. The main important aspect why we have to consume or these type of the material, that waste material, those are going to generate the less amount of this carbon dioxide. So the main important aspect or the aim is you have to lessen that the burden that would be happen on your natural resources. Why? Because year by year, because of your globalization or your urbanization, so we are going to mostly depends upon the natural resources, where the dependency was more. That's why once if you take it, these waste materials are the recyclable materials, such that we can utilize less amount of the natural resources, such that we can create certain amount of the sustainability there. Through your sustainability development goals or your eco-friendly concrete, are where you are going to recycle your waste wash water, and you are going to reduce your water consumption. So generally these type of the techniques, it would helpful in order to reduce your amount of your materials. What are the materials you will use for the construction aspect there? Practically whenever you are going to use your waste material, so the partial replacement would be there, not 100% we can replace, but we had one concrete where geopolymer, we can replace 100% cement with your fly ash and GGBS, and we are going to whatever the energy consumption that we are going to have, that energy consumption would be get reduced through your reusable materials, that will become your eco-friendly construction materials. So in order to achieve that, we are going to use that waste material there. For example, already I had explained that fly ash, GGBS, silica fume, etc. we can use inside the concrete there. So other important building material are eco-friendly, where you are going to have the ashcrete. So generally, in Indian typical conditions, we had two different types of ashes that would be produced. One is nothing but class F, and second one is nothing but class C. So where your class F is nothing but where your calcium content was less than 20%, we can call it as an class F. If the calcium content greater than 20%, we'll call it as an class C. So whenever most of the ashcrete are for the concrete production, we are going to use only the means these class F type of the fly ash, where it is abundantly available and it contains more amount of the silica content. So in order to manufacture your green concrete, so you can utilize your fly ash, and you can add these fly ash as a main ingredient for the production of your cement. So for example, once you had calcareous material like lime, you can mix your certain amount of the fly ash along with the water, and you can make your conventional cement that nowadays we'll call it as an PPC, where we are going to add certain amount of the ingredient inside that along with the lime. So sometimes we can make this ashcrete with replacement of not 100%, up to 25 to 30% we can replace with this particular amount of the cement. The most important aspect that the benefits we are going to get through your fly ash is nothing but we can reduce your bleeding problem, where your bleeding would be get reduced, and it is going to give you the later strength after 28 days. It is also going to reduce your shrinkage problems, so where your volume changes would be get reduced. But compared with your OPC, so definitely these traditional concrete is going to help you out in order to get the good amount of the results towards your workability, strength, as well as the durability there. So whenever you are going to make your these particular amount of the ashes, so generally these alkali silica reaction or alkali silica reactivity, whatever the means that you are going to get from your silica, more abundant of silica that would be present, by using this environment friendly material, we can have the more amount of the resistance there. So next, already we have discussed about this blast furnace slag. So next one is micro silica, 70 to 12%. You can utilize that, and you can make your eco-friendly. And third, fourth other ingredient is nothing but your aggregate replacement. So once if we are going to have this particular amount of the cement, obviously we are going to replace this aggregate material with recyclable, where you are going to have this means demolishing waste, or your whatever the waste that was generated from the construction industry. So that waste you are going to utilize, and we can produce our traditional concrete. Some of the aggregates that you can have, the paper or fiber or the waste plastic or waste glass or the concrete debris, these are the some of the major ingredients you can have in place of your aggregate replacement there. So in order to have these waste materials, that material you can convert in the aggregate part and you can add inside the concrete. So now we'll have the papercrete. This is one type of the fibrous concrete, where your waste paper that you are going to recycle, and you are going to reuse that material as an aggregate. We are going to convert that in the terms of aggregate, and we are going to add inside for the concrete manufacturing there. While you are going to have these most probably these small quantities, so we are going to have certain amount of the effects whenever you are going to have this production there. So it does not entirely replace the cement, but small quantity, up to 10 to 20%, we can use this material for the production of your concrete there. And concrete debris, where you are going to have this waste that was dumped, that waste you are going to use where the landfills are certain amount of the usage of your virgin materials, you can reduce that part there. And post consumer glass, where you had, this is the very inert material, where up to certain extent you can replace your aggregate inside the concrete, And once if you are going to have this chemical composition was very different compared to that. Generally, we take our aggregate, we had certain amount of specific gravity, water absorption, and your moisture content. All these ingredients are going to place an important role. Once if you use this glass, post-consumer glass, generally it would help you in increasing your durability, and wherever you are going to dump that material, and we can reduce that landfills waste there. So this is also one option where you can have this post-consumer glass. And next other important is the plastic waste. So plastic they are going to dump at the different locations where you had this non-biodegradable material. So where you can utilize that plastic up to 20% inside your aggregate, you can replace, and you can add inside the concrete there. So these plastic waste, whenever you are going to use that up to a certain limit. So it is a one of the smart move where you can use this waste material alternative towards your regular construction practice or the regular aspect there. So the lot of research is going on this plastic weight, but most probably one of the biggest disadvantages, thermally it was not resistance, where your temperature was very high. There may be chance for the melting of that particular plastic there. And what are the major potential alternatives that whenever the more amount of the carbon dioxide is emitting, so how we are going to reduce this amount of the carbon dioxide? So generally means we had the alternative towards your traditional concrete or the eco-friendly concrete, where we are going to have the NovaSem. So this is one of the major material where it was developed in order to absorb certain amount of the carbon dioxide by using your magnesium sulfate. This is the one of the new type of the alternative where the manufacturer they are going to absorb certain amount of 0.6 tons of your carbon dioxide. So where approximately your traditional concrete would emits up 0.4 tons of the carbon dioxide. So it was in the trial stages where it will it can be used in the construction industry. Once it was out in the market, you can utilize that material for as an eco-friendly inside the concrete. So it may be protect our health or as well as our earthen surface where the lot of carbon dioxide would be get emitted into the atmosphere. So it was in the trial and the research base where we can make our concrete as an alternative or the traditional concrete there. So once if you go for your sustainable, generally we will use for the longer life or the lower life cycle cost, where you are going to use this sustainable concrete construction. So most probably we have to reduce our amount of the cement manufacturing. Once if you are going to have this concrete, generally we'll use for payments or for the regular construction aspect, where the average service life, if you consider 30 to 50%, is that alternative towards the concrete, the material will give same amount of the service life, or what was the life cycle cost. See, generally if you take your cement, generally we'll have the more amount of the service life, means approximately 30 years 40 years, means with proper maintenance we have a longer life there. So whatever the energy or your resources that you are going to use for your construction aspect, your maintenance should be very less throughout its service life. Like that you have to get your material to be work out at the site locations there. And safety and reliability also very important. So once if you are going to make your concrete with this sustainable concrete, where because of your vehicles or more amount of the traffic, so generally the lot of amount of the means this rust or certain amount of the burns that would be get developed because of the bad weather also. So the payment would become the damage would be very high. So once the resilience also should be there, where you had certain amount of the man-made disaster or the natural disaster. Once if you construct any concrete structures alternative towards your materials there, so more amount of the carbon dioxide release would be there. So that material means once if you are going to have that material, so it should be get repaired very easily, such that it will create certain amount of the sustainable construction aspect there. Fewer traffic distractions. So once if you are going to have the lengthy way or closures, generally time to time we had more amount of the carbon dioxide emissions, that where we have to reduce that. So now whenever you are going to focus on your building materials alternative towards your man-made materials there, the main deal with this particular amount of these materials, where your focus is on mainly on the simple construction. So where it should not damage your environment and you should not consume your fossil fuels. And if you are going to focus on these methods, generally we had certain amount of the glitches where you cannot address all the issues. So that's why you had certain amount of the natural materials where you can use for your construction aspect. One is timber, other one is straw, hempcrete, as well as your earth. All these materials you can use as a natural building materials. So we had the abundant source where on the earth, and we can extremely use these materials for the construction aspect. Among that, why we have to go for these natural materials? So the emission or whatever the carbon dioxide that it was get released into the atmosphere by using your straw or the hemp, these amount of the insulation or amount of the store of this carbon dioxide was very high, and the carbon footprint that would be get generated through your building, it would be get reduced. And more amount is that the eco-friendly, where you can get this material through your naturally you can grow that material and you can consume that material, where your hempcrete or the timber frame technique or your building with the straw. I'll show you some of the pictures where we had certain amount of these materials. You can use it very easily, and quickly also you can go for the construction aspect. So this is one of the best example. This is the straw bales, where you can construct it with your wheat, rice or the rye or the oat straw, where your structural elements, and it had the very good insulation that you can use for the construction aspect there. These are the one of straw bales where you can utilize this method for the construction aspect. These are generally the natural building construction projects where these straw bales means generally used for the sustainable method, where you can reduce your usage of your virgin material, that it is going to get means create certain amount of the carbon dioxide into the atmosphere. The amount of the energy needed for your heating and cooling, that already in the previous slides I explained about the operational maintenance, operational carbon, it would be get reduced. Your heating and cooling also would be very easier for this type of the materials there. And advantages for the conventional method, where you can have the straw nature, that straw should be suitable for the construction aspect. Your cost would be very less, easy availability, and but the main important is high insulation value. The disadvantages is nothing but it would become rot. It means with less amount of the time, and we required huge space in order to accommodate this straw inside that particular amount of the construction building there. So the most probably the main important is the moisture probes, where your straw bales you have to collect and you have to store. Once the moisture content was left out, means your weight of that particular material will drop down there. The moisture level means it does not aid to break down that straw, but the main important aspect is that the amount of the moisture content that was present, that will plays a key role in the construction of these type of the buildings there. So this is the material where we are going to use for the natural building material, eco-friendly material, where you can use for the construction aspect. Next one is nothing but your grasscrete. So where this is the one type of the technique we'll follow, at the walkways or the sideways or the driveways, where you had a certain amount of the grass or your flora you can grow such that it will means reduce your means overall usage of the concrete, where your storm water will be get absorbed, and your drainage water also means you can utilize that, and you can means grow this type of the grass at that different locations there. And next one is nothing but the rammed earth, where this is the one type of the technique where you can use for your foundation or the floors, or chalk or the lime or the gravel you can utilize. The most ancient method, the sustainable building method, is nothing but your rammed earth. You can use that for your construction aspect. The main important is what type of the soil you are going to use. The main thing is that your design should be appropriate, and your local climate also should help you out in order to utilize this particular type of the material for the construction of your building there. And these rammed earth mainly involves the compaction of your subsoil, where the different proportions of your sand or the gravel and clay, and will stabilize that. We had the extensively certain amount of the formwork, where you are externally you are going to place as a mold, and in that we are going to add this particular type of the means soil there. So soil generally for the depth of 10 to 25 centimeters, approximately 4 to 10 inches, where you are going to compact it. And once the compaction with the different batches, so there you can erect your formwork, and you can means use for your natural construction. And the modern construction, generally we'll have the employment means pneumatically, or we are going to tamp that in order to reduce your increase your stability of the soil. Means here we are going to use a very less labors, so means compared to that of your modern constructions, and you can utilize that for the regular construction aspect there. So generally, if you have this means rammed earth, where your compressive strength of these particular earth will increase after you are going to go for the curing. Means you are going to use the water, and cement stabilization also we can go with approximately the period of 28 days, where you are going to get the good amount of the strength. Compared to that of the means walls, all these things, you can use this conventional type of the for the footing purpose, or the concrete slab base, where you can use this type of the construction aspect there. So it was environmentally sustainable, where you can have the good building technique, or cement or other chemicals you can add. Once the locally available materials means you cannot get the soil from the other location, because of that you had the ambient energy will be get lowered. The transportation energy will be get increased if you get the soil from the different locations, and less amount of the waste that would be get generated. But the main important is the lower or the subsoil you have to you have to conserve that particular amount of the soil in order to have certain fertility. The topsoil you can utilize for your agricultural purpose also. For the foundation purpose, if you are going to have your energy consumption for means soil would be get minimal. So generally, once if you go for the construction aspect, we'll get the earth from the different means in order to compact that, or in order to go over the leveling aspect, we'll get the earthen surface from the different locations, where your energy consumption would be more. But here your cost or your energy consumption would be get reduced through this rammed earth technique. Next is nothing but your hempcrete, where you are going to have these hems, or these type of the cannabis sattva plant. These are the nothing but the species where you can grow this plant. Generally, this is nothing but the hemp. This is a biocompost material, where you had lime, sand, or your pozzolanas. You can add inside that, and you can prepare this material. Generally, in the market, they will call it as an hempcrete, or the canobiate, canosome, all these things. And the hempcrete, where you'll have the carbon negative. One of the major is it is going to consume your carbon, and where these type of the ingredient that the contractors can utilize in order to use for your construction aspect there. Generally, these hemp sheaves where your wood core, you are going to keep your hemp plant and lime water as well as your binding agent. So these blocks, see, it will look like this. The main source of this hempcrete is it contains high amount of the silica content, and where you are going to have these raw materials, you can blend and you can utilize this particular amount of the blocks for the construction aspect. So the hempcrete you are going to means based on your aging, packing, all these things are going to place an important role. It is very light, very durable, and it had the very high insulation properties in order to get the good amount of the strength. So how we'll prepare all these things? The raw material we can collect, and proportionally we'll dosage the different types of the soil or lime as well as your water, all these things, and we'll mix together and we will make the block of 6 and 30 centimeters based on your special press. The amount of the thickness you require, the more amount of the press you are going to have, and these brings the harden where the blocks are you are going to keep at one particular location where you are going to go with the open air drive. So once the block was dry, after 6 to 10 weeks, you can utilize the that blocks. You can take it and you can use for the construction aspect there. And next other important is what are the main applications where you can use that for insulation of your walls, interior and exterior, or your floor finish, means underneath of the floors for the plastering purpose, insulation for your old buildings, for your renovation place, you can utilize this hempcrete there. So these hempcrete, it was a more traditional the mass material where it absorbs certain amount of the heat and during day, and it night time it is going to have the cooling nature where you have certain amount of the energy cost saving. You need not to use your air conditioning system. All these operations would be get reduced, not 100%, up to 10 to 20% we can utilize this. The construction aspect, while you are going to go with that, your consumption of your time or all these things, it would be get reduced. And it was a quasi ductile behavior where it was somewhat ductile compared to that of your regular construction materials or more brittle material, and we can reusable without affecting the structural properties, the amount of thickness or the width or how much amount of the layers you are going to press. All these things are going to place an important role. And it is the microbe where you had the parasite resistant material. The fire rating, whenever the time of this fire, you had 60 to 120 minutes, where means it will take longer time to burn, and it had certain amount of the insulation properties also, heating and cooling nature, and lightweight, and you can transport it very easily, you can handle it very easily, and you had the excellent heat and sound insulation properties there. So this is about your hempcrete. They have certain amount of the disadvantages also. One of the major thing is that lower compressive strength, and it cannot be used for your direct load bearing frames. Means generally for your walls, all these things for the insulation purpose. And more important thing is that a lot of places this hempcrete is illegal and they are not going to use, and in order to ship this particular amount of the materials are also difficult. So, and whatever the forms that you are going to consider, means this should be continuously raised, then only we can utilize that for your building construction aspect there. Next other important is bamboo. It is one of the major uh, eco-friendly material where it had the high compressive strength and low amount of the weight, where you are going to means support as an support for the concrete, especially where the bamboo abundantly available. You can go for this particular type of the construction, especially in the areas of Maharashtra. They're going to use this material for the construction aspect there. We have the Bamboo Society of India where these bamboo means we have the different species name, that species which are suitable for the construction aspect, generally for your scaffolding purpose or your bridges or your houses. You can utilize this for the construction aspect. So the bamboos are very fast growing, means where they are going to grow 3 times faster than the regular species of the plants, and they are renewable and you can utilize for many purposes. Generally, for the housing purpose in the olden days, they are going to use this as a major eco-friendly construction materials, where larger areas of applications, residential shortages where it was there at that particular locations, they are going to use this one. We had this type of the foundations or for the walls or for the roofs. We are going to have the different types of the means structural component where you can directly erect these members at the different locations there. One of the major advantage whenever you are going to go for this type of the building material, it had the high amount of the tensile strength, and fire resistance is also very high, where it can withstand up to 400 degrees centigrade. And elasticity, where it had the generally it had certain elastic properties, where earthquake prone locations these material can have the huge impact that we can utilize this material. And the weight of the bamboo compared to that of the regular materials, the weight was very low, and it is very easy for the transportation and for the construction also. And other building materials apart from this regular construction of bamboo, you can use your cement or the asbestos, where means it does not pose any danger to your health. So these type of the materials you can utilize, and cost also very less and easy to use, and it had the great demand where you had the earthquake prone location. But the disadvantage is mainly the preservation. So why? Because if it was get exposed to the outside atmosphere, they are going to absorb certain amount of the moisture, and there may be means the volume changes that would be happen, that will call it as a shrinkage. So shrinks much greater, especially the amount of the water loss inside the bamboo would be very higher. So they are, because of that there would be greater amount of the shrinkage problems. And other one is durability, where your bamboo was sufficiently means it was not resistance towards your durability. Why? Because you had certain amount of the attacks from the outside, that was nothing but your insects or the fungus that would be attacked, means where your durability would be get reduced there. And jointing, where you have to apply certain amount of the technique, where these joints may fail very easily. If your joint fails, there won't be means much amount of the strength to carry the load. But the reliability of these bamboo, whenever you are going to utilize for your jointing purpose, what extent it can carry the load, that is also one of the major challenge whenever you are going to go for your site condition there. Next, other important biomaterials, where you are going to interact with your living system. So means your concrete or your plastics, admixtures, asphalts and soils. We had other concrete, we'll call it as an bioconcrete, where you are going to have this means very strong durable material you can produce. You can have the overall durability, where you have less amount of the cracks there. Maintenance is also very less. That will call it as an autogenic healing, where that will call it as an means these type of the concrete. That type will call it as a bacterial concrete, or the sealing of the cracks there. By itself, it is going to seal the cracks. That type of the concrete will call it as an bioconcrete, where you have the bacterial spores or the calcium lactite. These type of the nutrients you are going to supplement. So these supplement, they are going to seal that a particular amount of the cracks there. The main important purpose of this particular amount of the capsules which you are going to supplement is in order to reduce the development of the cracks. Generally, we will produce a bacteria. We have to develop that in the organic way, and then that you are going to create certain amount of the spores, where you are going to add inside that particular amount of the concrete structures. Once the capsule was break down, your spores are become active, and they are going to react with your lime as well as the water, and they are going to formulate your calcium lactate and the nutrients. These are going to fill the cracks. So the prevention of the cracks would be happen through your these bioconcrete. And other important material, construction material we are going to use is mycelium. This is one of the means ingredient where you can use these material for the construction aspect. Here, this is one of the major where you can utilize this particular amount of this mycelium as a main ingredient in order to go for the construction aspect there. Next one is the natural fiber, where you can use this material from either from the animals or your plants, where you are going to take the fibers, and these fibers are going to add inside the means for the construction aspect. So most probably the natural fibers we are going to convert into the sheets, where it is going to absorb your sweat or some other liquids, and these type of the ingredients generally we are going to use for your construction aspect. So we had the coconut cotton plants, where you can derive certain amount of the cotton fibers, and we can use that texture for your clothing or various colors you can produce. That type of the natural fibers where you will prefer for the made over your synthetic fibers, means that type of the clothing you can use inside the as in your construction means for your windows or the doors, all these things. What are the properties that we had? The seed fibers, leaf fibers, fruit fibers, stalk fibers, bast fibers, like that we had different types of the fibers where we can utilize that fibers and we can go for the construction aspect. And animal fibers, this is the keratin or common examples where you can use these fibers for the silkworms or sinew, wool or the mohair. These are the some of the different types of the fibers that are available. So natural fibers generally widely used for the construction aspect, where you are going to have the synthetic polymers you are going to combine and you can produce this fiber. These natural fibers have the high amount of the insulation and the noise absorbing panels are there. So most probably you can use these fibers for the construction aspect. Widely these type of the plant fibers have the industrial applications for the cotton fibers, where you can use for the textile industry. Other hemp fibers or the jute fibers or the flax fibers from the plant you can utilize for the construction aspect there. Natural fibers they can use for your manufacturing of your medicines, or it will act as a biomaterial, where your industrial carbon dioxide emissions you can reduce up to certain extent. So this is a waste paper, you can use that for the construction aspect. These already papercrete we had already discussed. Where the means waste paper you can use as a particle board at by using the resins, and mechanical properties, the percentage of the bonding resin, it will help you in order to get certain amount of the strength there. This is nothing but the glass bottle construction, where you had the good insulation for your green building. And glass bottles generally we'll use for the foundation trays, or means you'll use for the top surface, where naturally you'll get your waterproof, where you can create certain amount of the layer there. And this is one type of the construction where you can utilize as a bottle construction. This is the shipping container. Recent years where multiple applications are the micro homes, they are going to utilize this material. These are the welded sites where you have the waterproof structure you can utilize for the offices, classrooms, or you can use for the mini restaurants or your food stalls, where your workshops, all these things where your container you can ship to the required location and you can go with construction aspect there. So generally these type of the shipping containers, where you can shift your external staircases or your landings at the different locations, where you don't have the, you don't require the permanent, but large number of people if you want to accommodate at that particular place, these doors and windows or your ventilation, all these things you have to have in the modular structure, where you can occupy directly, and it should means as an best alternative with less amount of the space you can utilize this. This is the type of the shipping container schematic representation. And last and final is construction of your home or these with the old tires, where external means you can see the picture that landing or your staircases, and where your product was very inhabited, waste tires you can consume, and you can utilize it for the construction aspect there. So the modular things where you can design and you can utilize like this, where you can have these tires and you can fill your other material and you can build this type of the construction aspect there. So this is about my total presentation, and
Hello, sir.
yeah.
Yeah. Do you hear me? Yes. Participants can ask queries in chat box, sir. Hello, participants. You can ask questions or your queries in chat box. Sir, questions are in chat box,
So
sir.
I'm saying that are the alternative
Yeah.
material GGBS other natural practical construction projects and mainly confined to the research. Generally, sir, means fly ash means in the cement industries they are already utilizing that, and GGBS are also, and most probably in many projects they are using this construction material, sir. Means especially this GGBS fly ash. Generally, for your green building concept, you can go with your means this natural material. But fly ash, GGBS, other alternative waste material, they are consuming for the production of your concrete also. Can you please explain? 1 minute, sir. Very good session. Thank you, sir. Rice base ash in concrete at 10% replacement decrease or 0% ash concrete. Would you? Yeah, 1 minute. So can you please explain the Portlandite limestone calcine clay? Sir, limestone calcine clay, this is one of the new means emerging topic that in IIT Delhi they are doing a lot of research. So directly the LC2 it was available. So in terms of calcium, you can have your cement, you can supplement that, and you can produce your LC3. So directly LC3 it was not available, and you have to go with that LC2 along with this cement. You can produce your LC3 there, and at 10% replacement of ash, the compressive strength is decreased to lower than 0 ash concrete, which would be the possible reason. See, generally means whenever you are going to replace that ash, whatever the means fly ash, we had different types of ashes that are available. So generally if you take your fly ash as a main ingredient, mainly the chemical composition, the silica content that would be present, and if you have the means 10%, 20%, 30%, so generally whenever you are going to use that ash, means is that reactivity was good, means silica was present. That was, and one more thing is the particle size distribution will plays an important role. So once if you are going to have this reactive silica, so definitely these silica will react with your calcium hydroxide, and it is going to form the secondary CHH gel. So that secondary CHH gel would reduce means it is going to means increase your strength there. What is meant by high performance concrete and how long it would be test to check the performance criteria? See, high performance concrete is nothing but generally whenever you are going to prepare your concrete, we had the 3 different factors that are going to contribute. Generally, workability, strength, as well as the durability there. See, one concrete we can produce high strength, means the code also suggests up to 100 MPa, 60 to 100 MPa. So mainly we are going to concentrate on the strength. And second, you have to concentrate on the durability also. If 3 parameters are included in that, so it is very highly resistant towards your aggressive environment. It is good amount among the strength, and it is having good amount of the workability. These 3 factors you cannot accommodate in one particular place, where if you are going to have this particular amount of the performance was in the better manner, that type of concrete we'll call it as an high performance concrete. So practically the supplementary cementitious materials already you can replace that, and you can utilize that for the construction aspect also. Is there any standards for the hempcrete? I don't have exactly that what are the codal provisions, all these things. Means it had certain dimensions that I already mentioned there. What are the material that contain calcium? Yes, sir. Lime as well as your GGBS. These 2 materials contains more amount of the calcium. If you take your fly ash, silica fume, rhizos cash, metacolin, all these things will contain more amount of silica. It does not contain calcium. Calcium based material is nothing but the GGBS. What happens when cool water and hot water added to the cement? So generally means if you add the water for the cement, it will react with that particular amount of the cement, and it will produce certain amount of the calcium silicate hydrate gel as well as the calcium hydroxide, and it is going to give you the amount of the strength according to the age. So hot water means it is also going to react, but means what temperature we are going to maintain, that will plays a crucial role. For example, if you prepare the concrete or if you kept in the hot water, definitely the rate of hydration will speed up, and it will give you the good amount of the strength also. And what about the physical and chemical properties of your limestone calcium clay cement? So 1 minute, I'll share one presentation related to your LC3. No, calcium clay and lime, they are not easily available. We have to extract from our natural resources. Calcium clay we have to means burn at certain temperature, so those are not easily available. OPC 53 grade cement production is minimum now. Can we use PPC in the higher grade concrete in the research work? Yes, sir. OPC nowadays it was not available, so PPC only available in the current market. You can use your PPC for your higher grade production also. You can produce your good amount of the strength there. What is hydration is very high in cement, and why manufacturing of cement heats very high temperature? Yeah, I already explained you about the clinkers formation. Each individual stage, it had certain amount of the preheating, where your particles would be get charged, and your 1 minute. Yeah, preheating, where your materials would be get decomposed, and your calcining, where the temperature CaO plus CO2 would be get separated. After that, there would be chance for the clinker formation. Means it is going to contribute the strength at that particular temperature. So once if you add that particular amount of the water, it will react and it will give you the strength. If you are not doing that much amount of the temperature heating, definitely means it won't react and it does not contribute any strength. What is the water to other content ratio with fly ash to achieve high strength? Okay. See, generally means water to cement ratio, that depends upon your grade of concrete. So if you are going to increase the grade of concrete, definitely your water cement ratio would goes down. So in order to have the high strength, definitely M60 like that, you can have to go with 0.31. If you want to go for M40, you can go with 0.38. So like that, based on your fly ash, definitely it will give you the better workability due to its spherical nature. So it required less amount of the water content also. But based on your grade, you can, whatever the water you select, that water is sufficient in order to go for your strength achievement. High strength, definitely you will have the admixtures. So kindly share the PPT related to LC3. Yes, sir. I'll 1 minute. Why PPC 43 grade is only used for plastering? Can we use the high performance concrete? Sir, I'm not getting you. That PPC 43 grade. See, PPC does not have any grade, sir. And
Hello, sir.
yes, sir. 1 minute.
Thank-
I'm sharing the presentation related to LC3. So can you see my presentation, sir?
Yes, sir. Yes, sir.
Yeah, here, sir, LC3, it's a limestone calcium clay where you are going to have the low carbon, means where you are going to blend along with your lime. You have the very less amount of the carbon dioxide emissions. So this is, you will have the limestone calcium clay as a main ingredient in order to reduce the amount of the clinker formation. For example, you can see here, it is the same method we are going to follow for the production of LC3. Means you had the clay and rotary kiln, and you will have the calcine clay, and there you are going to add your lime, and this is the main ingredient. See, you can see OPC, you had more amount of the clinker percentage, less amount of the gypsum. If you take the PPC, you can see that fly ash, clinker as well as the gypsum. But if you see LC3, the difference is that you have the calcine clay, clinker, gypsum along with the limestone. These four ingredients will call it as an nothing but your LC3. So for example, if you take here LC3, so 50% of the clinker, so we had the CO2 plus fuel combustion. So 30% of calcium clay, 15% of lime, and 5% of gypsum. See, here gypsum we are adding 5%, but your carbon dioxide levels, how they are going to produce. If you take here, if you compare the both the things, where you had the carbon dioxide and fuel combustion was very high, but here up to certain extent we are going to reduce that only at the clinker formation. Here we are going to have this fuel combustion where some amount of the carbon dioxide will be get released. Here 30% of calcium clay, limestone as well as the gypsum we are going to use for the production of your LC3 there.
Hello, thank you very much, sir. It was a nice and wonderful session, sir. So, sir, before going to end the session, I'd like to ask all participants to just open their video so that we have a photo for attendance records and ATAL records. So that's why. For just for 1 minute, sir. Hello, participants. Now you can switch on your video, please. Sir, Dr. Mallikarjuna Rao, sir. Thank you very much, sir.
Yeah, thank you so much, sir, for inviting to deliver this lecture. Thank you very much, sir, for
Thank
the
you
loss
again.
management and
Yeah. Thank you to the speakers, first session speaker and second session speaker, and all participants to making having a patience. And tomorrow we'll meet at sharp 6 o'clock for third session. Please enter the feedback form. Session 1 and session 2 are both are different. You have to fill both forms. It's in a chat box. Session 1 feedback form has been closed, sir, for all participants. And session 2 feedback form will be closed on 9:45. Be quick.
All the participants listen carefully that session 2 feedback is already posted on the chat. It will be closed at the end of the session at 9:45. So participants, please check your chat box and fill the feedback of 2. And it is shared in your WhatsApp group also. Thank you so much for joining the session.
All participants, thank you once again. We'll meet tomorrow at 6 o'clock. Third session.